All right, so I'll do one thing. One man, okay, one man has three daughters, okay, three daughters. So he has bought three dresses for each daughter, one dress for each daughter, okay. All the three of them are same in color, same in design, same material, everything same, but heights are different because three daughters are of different ages. They're not triplets even, so they're all different ages. So based on their height, he has to buy the cloth, right? So he bought three dresses. Each of them are same in color, same in design, everything same except the height, okay. And he kept it in a dark room to make them surprise, okay. So he made every daughter, each one daughter, to go inside the room and take a dress blindfolded, okay. In that scenario, what is the probability that each daughter gets wrong dress? Each daughter, all the three got wrong dress. What is the probability? Okay, you can think in any way, classical way, any way. You tell me the answer. But the answer would be very easily found out in the case of classical way. Think like that, you will find the answer. No, probability will be a fraction or decimal, right? It will not be a proper number. It will not be an integer. It should be a it should be a fractional number. Is it 1 by 3, 2 by 3? We'll check on it. Yes, 1 by 3 is the right answer. I'll tell you how. In the room, there were three dresses. Okay. First daughter goes in. Out of three dresses, she'll select one. Okay. That one should be not not a match to that girl, right? And that should not be the actual dress for that girl, right? In that case, out of the three dresses, one will be her dress, and other two will be other two daughters' dress. So she has to select a dress which is not matched to her, right? So out of three, two she may select because she is going to select which is not matched to us, okay, to her. And then two dresses will be there. Next, second daughter goes. She has to select a dress which is not matched to her one. And obviously the third daughter goes in. She has to select the only one dress, sure event, one, no other go, right? So what is the possibility ultimately? The value will be 1 by 3. Okay, that's how we get it. This is your answer. This is how we'll think. All right. And then let me ask you another question. From a pack of 52 cards, okay, deck of 52 cards, you're going to select two cards. What is the probability that those two cards are either king or queen? What is the probability that those two cards are either king or queen? I'm selecting two cards. Okay, those two cards should be king or queen without replacement. So you'll think in terms of combination. That's fine. You'll find the answer. Charan, if with replacement, then it will be 3. No, it will not be possible, right? So 3 by 2 will be there. So eventually you'll have a, see, this is for without replacement. Obviously the daughter will go in and select a dress. She'll come back with the dress. There won't be any replacement content, right? So it is understood that you should not replace, right? If you replace it, then where is the fun? Blindfolded, dark room, take a dress. So if you take an without replacement, okay, with replacement you can find, but still it is not based on the question. Okay, what is that? Is that 8 by 6, 63? Which one? Oh, fine. For the card, out of 52 cards, you're going to select 2 cards, either king or queen. So this is the possibility, right? This is the question. So what is the possibility? Okay, so my probability is quite simple. Out of 52 cards, I'm going to select 2 cards. And that card should either be king or queen, right? So how many kings and queens are there? So I'm going to select only that card, right? So either king or queen means totally 8 cards would be there. Out of 8 cards, I can select any 2 cards. I'm not telling whether it is a king and a queen. It can be either king or queen, right? Could you understand that? So it can be king or queen. So it can be for one king, one queen, or first queen, second king, or both of them king, or both of them queen. That's up to us, not a big deal. In that scenario, what is the total possibility? This is the possibility. So based on the question, you think, okay, you might have thought like this: first one may be king, second one may be queen, or first one queen, second one may be king. So these two only the possibility you would have thought. But I told you either king or queen. So it can be either one of them king and queen, or both of them to be king, or both of them to be queen. That is the possibility. So what is the ultimate answer? You will get 8 times of 7, 52 times of 51. Okay, so 7, 51, 7 will not go. So these two, in terms of 4 and 2 times, this is 13 times. Okay, anything else? Nothing. 14 times of 650, 663. 14 times of 663. Okay, you get it? That's it. Okay, in a classical way, how do I define? Same process. See, first I had 52 cards. I'm going to select any one of the king or queen card. Totally 8 cards are there, king or queen altogether. So I can select only one. How many possibilities are there? Out of 52, 8 possibilities are there. I'm selecting 8. Okay, and then I will have 51 cards. I will have 51 cards, among which I am going to select still king or queen. So out of 8 cards, I have selected one already in this process. So leave it. I didn't replace it. So remaining 7 cards will be there out of 51 cards. 7 cards, which is my favorable event. Okay, so altogether I have to select 7 cards. This is my possibility. See, here you will have like this, divided by 1 into 2 and divided by 1 into 2. So this 1 into 2, 1 into 2 will get cancelled eventually. That's how we get this. Okay, all right. Let's go to the topic for the day. Area and volume. Okay, first we'll deal with area. After the break, we'll deal with volumes. Okay, so area in the sense, it's very simple. First of all, we have to understand one thing. It's a graphical part. Let's say x, y, x-axis, y-axis. You have, let's say, you have an amoeba shape like this. Okay, you have an amoeba shaped like this. Random. What is the area of this amoeba? How do I define it? You will deal with integration. Yes or no? Had you learned these integration stuff in your schools or colleges, you will think like that. See, this is shapeless. It is an irregular shape. Okay, so for this case, you have to deal with integration, which is not enough. Deal with certain ideas, which is regular in shape. So that's what I want. Okay, regular in shape. So regular in shape means it'll either be circle, square, triangle, rectangle. It goes on. Okay, so all I want is silly idea. How do I define it? I'll tell you. See, first we'll learn this dimension. This is what we call single dimension. It's a straight line. Okay, using 2 points, I join them, I'm getting a straight line. It will never form an area. Why? Because it will never occupy some space. This just a line. Okay, it is not occupying a space. But what if I get a value, I get a shape like this? It is occupying a space in this bigger space. So let's imagine the board to be a bigger space, okay, bigger area. Among this area, this shape is occupying some space. Okay, occupation of space is called as area. So this space, no, This is what we call area among the given, let's say area itself. Okay, given bigger area, for a given bigger area, this area is being occupied, this space is being occupied by a particular regular shape, and this is called as area. What if I deal with this lines? We call it as perimeter. These two are the very basic idea and major idea which we have to deal with, areas and volumes. Okay, basic one. Okay, so let me tell you the basic idea again. In this case, single dimension not a big deal. Two dimension, in the two dimension, first we'll deal with three side shapes. Three side shapes means you have this one, let's say random one. One minute. All right, so let's take the letters. So the sides are A, B, C, and we call them as scalene triangle. Okay, they are called as scalene or scalene triangle. Scalene or scalene triangle. Here, two sides are equal in length, and we have one other base, and we call it as isosceles triangle. And all the sides are equal. We call them as equilateral triangle. And this one, we have this 90 degree. This we call it as right triangle. Okay. See, I want to find perimeter and area. So we'll deal with the perimeter first. Okay, what is perimeter? Circumference or the corner lines. Okay, what is the complete length of this? Okay, length of a particular figure, complete length of a particular figure, we call it as perimeter. Here complete length is a plus b plus c, adding all the sides. Okay, a plus b plus c, and here it will be 2a plus b, right? A plus b, 2a plus b. Here it is 3a, and here it is a plus b, and here it will be there, no value. Let's say c itself, not a big deal. So a plus b plus c, where c equals to root of a square plus b squared. You remember this? You have to remember this. Okay, so a plus b plus c, whereas c is equal to root of a square plus b square, because using Pythagoras theorem, because it is right triangle. So these are all perimeters. So what about area? Area is quite simple. Here we have an area, scalene triangle. We have one particular idea, root of s into s minus a into s minus b into s minus c. Okay, whereas s is equal to semi perimeter, half of a plus b plus c. We call it as semi perimeter. So whenever you don't have any idea about this area, no, for finding an area, we must have half into base into height, no. So what is base here? B is base here, height is a for now. Let's imagine base and height itself. Okay, they'll give you height and they'll give you base. You can easily find the answer with this. But here we don't have any base. We can take C as a base, B as a base, A as a base. But what is height? We don't have any perpendicular length. So we cannot tell particular area about it. So I can use this formula. This is a generalized formula for any idea. Okay, any kind of triangle. Okay, s times of s minus a, s minus b, s minus c, all under the root. Okay, whereas s is equal to half of a plus b plus c. So here the same process. How do I get it? Root of s into s minus a. I have 2a, s minus a, s minus a, s minus b. So I can write s minus a whole square, s minus b. Okay, whereas s is equal to half of 2a plus b. We'll use it also. But here, if I use the same process here and solve it, ultimately S is equal to 3a by 2, no, 3a by 2, then 3a minus a by 2. You will have like 3a minus a, 3a by 2 minus a, 3a by 2 minus a. So everything will be there, no. Altogether, you will have ultimate answer to be 3 root 3 by 4 a square. After solving everything, you will get this answer. And then this is my ultimate formula, not a big deal, half into base and height. Whereas considering b as a base, a will be height. Considering a as a base, b will be height. So eventually I can write like this, half into ab. Can I? Yes, I can. Half into base and height. Instead of that, I can use half into ab, base height or base height, whatever. So in general, I can tell in area case, I can tell one thing, half into base into height. Sum of sides. That's it. Okay, copy them. All right. Then comes square and not parallelogram. Let's go with square and rectangle itself. Okay. Hope you have copied or take screenshot. All right. Okay. So let's go to square and rectangle part. Square. Okay. For this, we know very well what is perimeter. A plus A plus A, 4A. Here, L plus B plus L plus B. Altogether, you will tell 2 times of L plus B. Okay. And then area, A squared here, here LB. Okay. So area LB. And you have diagonal. One more thing here. So let's say diagonal. Diagonal value is A root 2. A root 2. Here diagonal value is root of L square plus B square. Okay, what is diagonal? The cross line. The line across the corner sides. L square plus B square. Okay. And why is it diagonal? Because in a square field or in a rectangular field, the longest line that I can draw or longest line, okay, linear space, longest linear space in a square field, longest linear space in a rectangular field, I can find or I can derive is diagonals. Okay. So longest line that I can put in a square or rectangle will be the diagonal. Copy them. Longest line. Okay. Then comes one other thing, uh, a slanted shape of these two. Like for this, we call it as rhombus. We call this as parallelogram. Okay, this is square. Here it is rectangle. For this case, a slant shape, slanted height of this case, let me tell you that. So this one, let's, okay, let's think like this. For this case, similarly, A will be the height, A will be the side. So perimeter will be simply 4A. Here, same, LB, L here, B here. So we can take any other number. So length should be, it is not necessary that length should be always more than breadth. You can think like this. In the previous case, I would have written LB here. It is possible. It is also possible. Let's take it. 2 times of L plus B. In most of the cases in your school days, you would have learned that length is always more than breadth. No problem. Both mean the same. Still, here area, they would give you diagonals. For this case, if they give you diagonals, half of diagonal 1 times of diagonal 2. If they didn't give you diagonals, they would give you a clue to get you the diagonal. Okay, they have to give you diagonals because rhombus area should be derived based on this formula only. Okay, similarly for this case, diagonal 1 times of diagonal 2, that's it. Okay, they have to give you. And one thing here, I can give you one idea. So let's say diagonals. Diagonals. So diagonals, let's say D1 is perpendicular to D2. D1, D2, they are all perpendicular to each other. One thing, and diagonals bisect each other. They bisect each other. You remember that. Okay. So diagonals bisect each other. Diagonals bisect each other at right angles. Okay, they are perpendicular to each other while bisecting. Okay, they bisect each other at right angles. They're not perpendicular to each other. They bisect each other at right angles. That's very important. Even though they are perpendicular, this is the main point. Okay, they bisect each other at right angles. So it would be like this. It will be 90 degree. Here they just bisect each other. They'll not be at right angles. They just bisect each other. Okay, so simply they bisect each other. You remember that. That's enough. Okay. All right. And then comes circle, and then some comparison shortcuts. I'll tell you. Comparison theorems. I'll tell you. Hope you're done with this. So let's go to circle. Circle and semicircle. Circle, semicircle. Let's say quadrant, and then a sector with angle. Okay. So circle perimeter. Here we don't call perimeter because they don't have In circle, we don't have any corners. So we call them as circumference. Okay, circumference. What is the formula for that? Circumference formula 2 pi r, whereas r radius will be given. 2 pi r, or I can also tell pi d or 2 pi r, whereas d is 2 times of radius. So instead of d, I can use 2 times of radius. I can use this also. Okay, pi d or 2 pi r. Okay, here circumference is nothing but the complete circumference of that, and then these line also, these segment of this line also. Okay, so if this is the radius, this would be pi r, right? Pi r plus 2 times of r, pi r plus 2 times of r. How? Altogether the complete circle will be 2 pi r. Half of that will be this area, right? I mean this line, the length of this line. So that line would be pi r, and then I'm adding these 2r. So 2 pi r plus 2r. Here also, this is a quadrant. Quadrant means 1/4. 1/4 of 2 pi r would be pi r by 2. Pi r by 2 plus 2r. 2 radius are there. Here are. So 2 radius are there. Here they've given you theta, right? Very simple. Theta by 360 times of 2 pi r. This will give you the length of arc plus 2r, 2 times of radius. This is radius, this is radius. That's how we get it. Okay, so to find the length of arc, length of semicircle, length of quadrant, length of arc, we use pi r here, pi r by 2 here, theta by 360 into 2 pi r here. That's it. Okay, simply. Okay, so this is my circumference content, and area would be very simple. We know the formula. Area is pi r square. Here half of pi r square. Here quarter of pi r square by 4, and then here theta by 360 into pi r square. Simple. Theta by 360 into pi r square. Very rarely you'll get this sector, so you might get mostly based on this semicircle or quadrant. Circle is fine, it's easy to find out, but still in a technical way you might get these two. Okay, so in a practical way, application oriented, let's say a wheel is moving. Okay, wheel is moving means wheel is rotating, it is covering some distance. Okay, when a wheel rotates, to cover a distance we have to deal with circumference. When a wheel completely rotates one time, it is covering some distance. That distance is nothing but circumference. One rotation is equal to circumference, n times of rotation is equal to distance covered. Simple. Okay, you remember that, always remember that. So circumference is equal to, in terms of wheel, one rotation is equal to one circumference. Okay, good question. In the case of square and rectangle, diagonals are perpendicular or not? They are not. Okay, in square it is perpendicular, in rectangle it is not perpendicular. Okay, so in the case of square and rhombus it is perpendicular. In the case of rectangle and the parallelogram, it is not perpendicular. Okay, all right, copy them faster. And once you know the formula, we are going to use the formula to find the answer to the question. We shall solve it. Let's go to the question number 1 in page number 166, area content. Okay, so we have got 13 questions. We shall solve it faster. If we have time still, let me give you the ideas about this. What is that? Volumes, and I'll give you a break. Okay, we are taking break at 11 o'clock sharp. Okay, so hope you are done with this. Page number 166. 166. Copy them faster. Oh, one thing, I have to tell you the theorem, right? Theorem in the sense, the comparison part, I'll tell you. Okay, so let's say you have a circle, triangle, rectangle or square. Let's say both mean the same for now. Okay, so rectangle or square, they mean the same for now. Okay, triangle and circle, so three things are there. When three objects are given or three shapes are given with the equal circumference, okay, all these circumferences are equal. Okay, first we'll deal with area, then it will be easy. First we'll deal with area. So whenever these three option shapes are given with equal area, areas of these three shapes are equal, then how do I define, they don't give you the area particularly. You can take any area, it can be pi r squared area, particularly some value, and you compare them with it, and then you need to find the sides, and then you have to find the perimeters. Based on the perimeter, you have to arrange them in ascending order or descending order. That's up to the question. Okay, let's do it in ascending order. Okay, so very simple. I'll tell you one thing. In the shapes, so we need to understand three words: shape. Okay, in the shape, no need to deal with the shape for now. Side, perimeter, and side, perimeter, and area. Okay, you remember this. Always think like this. More the number of sides, if you have more number of sides, okay, more will be the area, lesser will be the perimeter. Always remember that. Okay, so when the areas are constant, all the area of circle, triangle, rectangle or square are equal. Okay, they are all equal. If I want to find the perimeters and then make them in arrange them in ascending order, very simple. More the number of sides, lesser will be the perimeter. Okay, so this perimeter will be lesser. Perimeter of circle will be lesser than perimeter of triangle, and then than perimeter of square in terms of perimeter. In terms of area, the question has to be like this. So three shapes are given with the equal perimeter. So whenever you compare two things, okay, so side will not be the variable here. So you're going to compare either perimeter or area. Okay, so when you want to compare perimeter, area should be constant, area should be equal, or otherwise perimeter should be equal, area should be compared, vice versa. So this is always constant. Okay, this is always a fixed idea. So we know that, no, by looking at the picture itself we can understand. And also remember, here we have three sides, four sides, here we have infinite sides. So three sides are there, four sides are there, infinite sides are there. Because if you focus, if you zoom the circle, you just draw a circle in paint in system and zoom it out, you will find small dots. The dots, if you zoom it out even, it becomes a rectangle or a straight line. It can be anything. It can be a straight line joined together. Okay, circle is nothing but a closed curve. Okay, closed curve joined together by a straight lines. Okay, closed curve made by a straight lines, we can tell that. Okay, and we have infinite sides for circle, three sides, four sides, and for a pentagon you'll have five sides, octagon eight sides, it goes on. But still they'll give you the idea here, they'll give you either perimeter equal or area equal. If they give you perimeter equal, you need to compare the areas. What is the area comparison? More the number of sides, I made a mistake here, I believe. Okay, first circle will come, then triangle will come. More the number of sides, lesser will be the perimeter. More the number of sides, more will be the area. Okay, exactly opposite. Okay, so this is the idea. Ultimately circle will have more sides, so lesser perimeter. Then comes in descending order. If you think in terms of descending order, this is the highest one, second highest will be this fellow, and third highest will, the last will be this one. Okay, perimeter, more the number of sides, lesser will be the perimeter, least, and more the number of sides, more will be the area. Exactly opposite of that. So this is descending order, ascending order. Okay, you understand? So simple, it's a theorem kind of question, fact based question. So they'll give you like this: circle, triangle, square. These three are given whose areas are equal. Okay, areas are equal. So if I compare it and find the answers, find the values of areas and find the values of perimeters, whose perimeter will be more? That can be a question. Or whose perimeter will be least? That can be another kind of question. Or arrange them in ascending order with their perimeters. Arrange them in descending order with their perimeters. So 4 types of question can be asked with this idea itself. So whose perimeter will be least? Circle. Whose perimeter will be most? Triangle. Ascending order? This thing. Simple. Okay. You understand? Any confusion in this? Okay, hope you're done. Let's do one thing. Page number 166. Let's solve the questions. Page number 166. Area. Question number 1. What is the question? The ratio of the area of squares to that of square drawn on its diagonal. Okay. So what is the area? Let's say area 1, area 2. Area 1 is the area of a square with its side. With its side is a square. Okay. And drawn on its diagonal. So let's do like this. So we have a square here, and we know the diagonal is this one. I need to form a square based on its diagonal. Okay, I formed a square which is based on its diagonal. Okay, this square and the yellow color square. Okay, what is the area between them? This is A1, this is A2. So what is the area of this one? Actually, side of this is A. Side of a square is A. Side of a diagonal is A root 2. So I'll tell A root 2 whole square. A root 2 whole square. Then what will happen? A square. Here 2a square. If I compare them, I'll get 1:2. A square will get cancelled. Eventually the answer becomes 1:2. Okay, you understand? Simple, right? You need to understand this diagram. That's very important. Okay. From 4 corners of a square sheet of a side 4 centimeter, 4 pieces each in the shape of arc of circle of radius 2 centimeter are cut out. The area of the remaining portion is very silly. We shall go to the next page because we have the diagram. Next question. So it is like this. They've given you a square whose side is 4 centimeter, correct? And from the square, 4 pieces of circle. Okay, 4 pieces of quadrant actually. From the corner, it is not circle completely. It is a corner quadrant circle. Okay, you have this kind of. This is what you have. These are all taken out. The quadrant of the circles from the corners of the square are taken out. Then find the area of the remaining portion, right? Whereas the radius is 2 centimeter here. What is the formula here? I want to find the area of the shaded region A, whereas I want to find the area of square first. So area of square A1, area of square minus 4 times of A2. Let's say A2 is, this is A2 times of 4, because whatever the value here, it will be repeated for 3 more times because the shapes are same, area will be the same. So quadrant of a circle here. Okay, so area 1 is 4 square minus 4 times of quadrant, area of quadrant 1 by 4 times of pi r square, 22/7, or even in the option it is given that in terms of pi, right? So let's do like this. So 4 times of 1 by 4 times of pi r square, or pi into 2 square. So pi into 2 square, that is 4. So 4 gets cancelled, 16 will be there, minus 4 pi will be there. Hence your answer is 16 times of 4 pi. Or if there is anything like this, 4 times of 4 minus pi, that is also the answer. I have taken 4 common outside. This is also right, this is also right. We have option B. That's your answer. Okay, 16 minus 4 pi. Simply using the idea, provided you need to think like this. From the corners, a circular portion is taken out. Circular portion from the corners of a square will be quadrant always, even for the rectangle also. Okay, I'll tell you. See, from the square, okay, so you have a square of side 4 centimeter, and you're taking a circular portion from the corner with respect to the corner. With respect to the corner, if we have the circular portion, so let's take like this. I have a square area, okay, rectangle area for now. From the corner, I'm taking a circular portion. It will be like this, right? It will be like this, correct? So this will be a quadrant of a circle. So this quadrant of a circle is taken out from the rectangular area for now. Similarly here, okay, I have taken circular area, circular portion from the corners of a square. Okay, if I take one particular portion, it becomes a quadrant of a circle, correct? So this quadrant of a circle shape will be repeated for all the 3 other sides, 3 other corners. So 4 times, 4 times of one quadrant, 4 times of one quadrant, we have got this. Whereas A2 is this area. So let's take A2. So A2, this A2, the overall part is A1. Okay, simple. You understand now, Meera? From the complete square, I'm taking a part of a circle from the corners. All right, let's go to next question. The breadth of a rectangular hall is 3/4 of its length. Okay, so here it means length is more than breadth. So let's go to the third question. The breadth of a rectangular hall is 3/4 of its length. Okay, so this is what given. And then if the area of the floor is 768 square meters, area of the floor, area is equal to 768 square centimeter square meter. Here it is square meter. Okay, fine, meter squared. The difference between the length and breadth of the hall is, we need to find L minus B, right? So with this you cannot find L and you cannot find L minus B straight away. First you need to find L and then B, then subtract it. We'll find it easily. So what is the area formula? Length into breadth for the case of rectangle, right? 768. What is B here? Instead of B, I can use 3/4 of L. No, I'm using here L into 3/4 of L equals to 768. Okay, so L into L square. 768 times of 4 by 3. I can cut it down. So this is for 76. 2 times 15, 18, 256 times. L square is equal to 256 into 4. Okay, 256 into 4 means 1024. So L square is equal to 1024, or even you can cut down straight away. Then it says L is equal to 32. 32 square is 1024. With this, I can tell what is B. What is B? 3/4 of 32, correct? 3/4 of 32, it is 8 times 3 times of 8 is 24. Then from this I can tell L minus B. What is L minus B? 32 minus 24, it is 8. So they've given you 2 clues. Straight away you can find the answer, provided you need to understand the formula very well. Okay, so breadth is equal to 3/4 of length, they said, and also area is equal to 768 centimeter squared. In that case, area is given, breadth and length comparison is given. Find the difference between length and breadth. We need to find that. Simple. Okay, this is one way. Okay. And another way, Can I solve it in another way? Yes, in terms of ratio, but you have to understand the ratio part very properly. I'm going to solve this in terms of ratio. These two equations, same thing, will solve it. So we'll do one thing. Let's solve here itself. Okay. B is equal to 3/4 L. No? Let me write it like this. B by L equals to 3 by 4. From this I can tell B is to L equals to 3 is to 4. And from this also I can tell B equals to 3x, L is equal to 4x. I want to find L minus B. Correct? What is L minus B? 1x. 4x minus 3x is 1x. I want to find x eventually. Right? So I know what is area. Area is equal to 768. What is area formula? Length into breadth. Okay. So length is equal to 4x. Breadth is equal to 3x equals to 768. Okay. So 4 3s are 12. I'll bring it there. X square is equal to 768 divided by 12. Okay. So 72. 72 now 6 times 4 times. So x square is equal to 64. From this I can tell x is equal to 8. Okay. So x is equal to 8 means the difference between L and B is 1x. 1x is equal to 8. You can straight away find the answer. This is one other method. This is one method. So I prefer this because you can straight away use the idea which you have learned in your school days itself. This one you need to apply extra idea. Even though you find the answer faster, this one is quite easier, right? You can easily find the answer faster in this case also, provided you know the calculation process well. Okay. Okay, in that case, let's find the next question. Fourth question. Copy this faster, this yellow part. All right. So next question, they said the length of each side of an equilateral triangle whose area is 9 root 3. The area is given. What is area formula of an equilateral triangle? Root 3 by 4 a square, right? So a here is 9 root 3 equals to root 3 by 4 a square. Root 3 gets cancelled. Bring this 4 there. A square will become 9 times of 4. 9 times of 4 is 36. Then a equals to 6. So I want to find the side. Side is 6 centimeter or 6 meter. Here 6 centimeter. That's it. Simple. Straight away apply the formula. You will get the answer. Fifth one. All right. A circular wire of radius 42 centimeter is cut and bent into the form of rectangle whose sides are in the ratio. Okay. Circle is being converted into a rectangle whose sides are in the ratio 6 is to 5. So let's take this is 6, this is 5, and the radius here it is 42. Question 4 once again. Fine. See, for this question they said they wanted to find side of an equilateral triangle whose area itself is 9 root 3 centimeter squared. So area is 9 root 3. We know the formula for root 3 by formula for equilateral triangle, area of equilateral triangle, root 3 by 4 a square. So root 3 gets cancelled. Let me bring this 4 there. 9 4s are 36. 36. A square. A square is equal to 36. Then A is equal to 6. Rupashri, okay. All right. So this case, you have a circle whose radius is 42 centimeter. Okay, and you're going to convert that in terms of rectangle. Okay, so that rectangle whose length and breadth are in the ratio 6x 5x. So let's take like this. In this case, what could be the area of the rectangle they asked? See, whenever they give you in terms of two-dimensional space like this, circle to rectangle or rectangle to circle, square to circle, whatever it is, you need to compare in terms of perimeter, because the length of the circle will be the perimeter. The perimeter is being converted into a square, sorry, rectangle here. How do I define it? Very simple. Let's take a lengthy wire, or lengthy wire, not lengthy wire. Let's take a wire itself, thread or wire, let's say. You can form a circle. You can do a circle, a circular shape. That will be length of the thread or wire. And you can also reframe that as rectangle, right? So I'm doing like this. So I want to compare the perimeters of these two. So perimeter of this will be 2 pi r equals to here 2 times of length plus breadth. Yes or no? Okay, no problem. 2 gets cancelled, not a big deal. So what is pi value? 22 by 7 into r is 42. Here it is L plus B. L is 6x, B is 5x. Okay, so this fellow becomes 11x. I can cut it down for 6 times. Okay, let's have 22 into 6 itself. Here we can get 11x. Correct? So 11, this is for 2 times. Then x is equal to 12. That's it. Yeah, we have this. We know x is equal to 12. I can use it here. So what is the area? Area is equal to L into B. L into B. What is L? 6x. What is B? 5x. So 30x square. 30x square. What is x value? 12. 12 square is 144. So 30 times of 144. So 3000. 4020. 4320 centimeter square. That's it. No need to find the values of length and breadth. You straight away use it, because they didn't ask you that. They asked you to find the area. Straight away you can find that. 4320. You understand? What did I do? I just compared the perimeter, because whenever you make one two-dimensional figure out of another one, 2D figure out of another one. Whenever you do that, you have to compare the perimeters. So perimeter of circle or circumference of circle, whatever it is, equals to perimeter of rectangle. Comparing them, we get the answer. Yes, Siddharth. Right answer for the next question. Okay, we shall go to the sixth one. Two equal maximum size circular plates are cut off from a circular circular paper sheet of circumference 352 centimeter. So you have got a bigger circle. In that circle, maximum sized two circular plates are taken out. However you take, so it will deal with diameter only. Okay. Let's take like this. Let's imagine like this. So the bigger diameter or bigger radius. What is the bigger radius? It is given that. No, they've given you the circumference, right? So what is the circumference here? 2 pi r. So 2 pi r, let's say capital R. So here we have got R1, we have got R2, let's say. Okay, so 2 pi r is equal to 356, 352. You can cut them. 22 by 7 into R. And also I'll tell you the shortcut a little later. Okay, that's the kind of theorem part, no ratio part, I'll tell you that a little later. So this fellow, it will be 352. Okay, 22 times 22, 352, will it go 22, 22, 1, 16 times it will go. This is for 8 times. Then R is equal to 56 times. So the bigger radius is 56. Okay. And this, we know the radius, the complete radius. I can tell this complete radius. Complete radius is 56, hence it will be Okay, the complete diameter will be, radius is 56, diameter will be double of 56. Still, I want to cut that into equal halves. That's when I'll get two different circles, two smaller circles of equal size. Okay, so this would be diameter of the smaller circle itself. That is, the radius of the bigger circle would eventually become diameter of the smaller circle. What is the diameter? So radius 56. So that actually R1 is equal to 2R1 is equal to capital R. Can I tell? From the bigger circle, the radius, if the radius is there, the radius will be diameter of the smaller circle inside the circle. Can you tell? That's how we get it. From the second tell, R1 is equal to 28. That's it. Okay, half of that. Right. So if R1 is equal to 28, what is the question? They asked you to find the circumference of the each circular plate. I want to find the one circumference. This circumference enough. Okay. I want to find circumference 2 pi R1. Circumference 1. Let's say 2 into 22 by 7 into R1, 28. We can cut it down for 4 times. So 8, 176 centimeter square. Okay. The shortcut is, let me tell you, whenever this is possible only for two circles drawn inside the circle. Okay, two equal sized circle drawn inside the circle, only two. Okay, two equal circles drawn inside the bigger circle. In that case, always remember circumference 1, circumference of the bigger one, let's say like this, circumference of the bigger one by circumference of the smaller one. Smaller one, circumference of the bigger circle by let me write it in a complete way. Why? Circumference of bigger circle by circumference of the smaller circle will be in the ratio 2 by 1. Simple. Always. Only for this kind of area. Okay. So we have a bigger circle. In that bigger circle, two equal sized circles are drawn. In that scenario only, this is possible. Okay. We have certain theorems, but still, there is a possibility. Copy them. You can easily find the answer then. All right. We are done with 6 questions. 7th one. How many tiles each 4 decimeter square, okay, will be required to cover the floor of room 8 meter long and 6 meter broad? Always remember 4 decimeter. So I'll write it here. I'll write the units here. 10 centimeter is equal to 1 decimeter. Okay. 100 centimeter is equal to 1 meter. From this I can tell 10 decimeter is equal to 1 meter. Correct? So 10 times of 10 will be 100. So 10 decimeter I can write. This is what I'm going to use in the next question. I mean 7th question. 7th question. Let me write it here. I want to find the number of tiles. Correct? So area of floor equals to number of tiles into area of tiles. Area of tiles. Okay. I'll write it here. 1 centimeter. I'm sorry. 10 centimeter is equal to 1 decimeter. 100 centimeter is equal to 1 meter. From this we are going to tell 10 decimeter is equal to 1 meter. This was the idea we just before discussed. Area of the floor, it is 8 into 6. I'm writing it as decimeter, 80 into 60 in terms of decimeter, because they've given you in terms of decimeter here. Their meter, so I'm converting that in terms of decimeter. Okay, and then n into square side is 4 decimeter. I can write 4 into 4 because area of the square is a square, right? 4 into 4. I can cut them out. So this is for 4 4s are 16, 16 5s are 80. Then n is equal to 300 tiles. Straight away you can get it. How do I get this? I'll write the formula here. L into B equals to N into A square. That's the formula. You understand? Okay. Next comes silly one. 4 decimeter square. 4 decimeter square. You have the rectangular floor. In that you have a square tile. Okay. Rectangular floor area will be length into breadth. Tiles area would be A square, no? So 4 decimeter side square. Okay. Square whose side is 4 decimeter. Got it? 4 itself area. It's not area. 4 decimeter actually the value. Okay. Could you please explain the formula? Sure. 7th one again. This one. See, you have a floor. You have a rectangular floor in which you're going to fix the tiles whose length is 4 decimeter. It's not 4 decimeter, 4 decimeter square. A square whose side is 4 decimeter. Okay. And then you have the length to be 8 meter, 6 meter. I'll write this way. 8 meter length, 6 meter breadth. So 80, 60 in terms of decimeter. You have the 4 decimeter square. How many squares can you place? So it will be like this eventually. So if you think, it will be like this. That's how that's how the square field will be fixed, right? Tiles you could have known already, right? So in a rectangular field, rectangular floor, you're fixing tile. How many tiles are required? Whereas this area is 4 into 4. How many 4 into 4 areas will be given for 80 into 60 area? Okay, 80 into 60 will be the area of the rectangular floor, and area of the square will be A square. For in this A square, no. How many A squares are there in this 80 into 60? LB is equal to N into number of tiles would be there multiplied by square of the area, square of the tile. Okay, so area of the floor equals to number of tiles into square of the area of the square. Solving them, N is equal to 300. You understand, ma? Length or area? Which one? Anju, it is given that, look at the question properly. Where is it? Will be required to cover a floor of room. Okay, for each 4 decimeter square. 4 decimeter square means length of the side is given. It's not area of the square. Length of the side is given. You get it? Length of the square. Length of the square is given. Length of side of square. Okay, fine. If you think like this, if it is area, 4 itself area, what will you do? The value will be 4. A square is equal to 4. So bring it there. So 80 into 60 by 4 will be 20 into 60, which is 1200. Do we have option? 1200 is the right answer. Then, is it right? No, it will not be the right answer. Why 4 decimeter square? Length of side, buddy. So you can have the square whose length is, I can tell, let's say length is 5 centimeter. Okay, I can tell a square of length 5 centimeter, a square of side 5 centimeter. I can tell like that, or 5 centimeter square. It is not 5 centimeter square. That's different. Okay, in that case, if they want to tell you like that, 5 square centimeter, that is the area idea. Okay, so always remember that. If it is side 5 centimeter square, 5 centimeter square. If they want to mention you in terms of the statement for the area, they have to tell you that 5 square centimeter. It is not given like that in the question. They said 4 decimeter square. Okay, you understand? Superb. Then question 8. The floor of corridor 100-meter long, 3-meter wide. Cost of covering the floor with a carpet of 50 centimeter wide at the ratio of 15 per meter is. Okay, so first you need to find the length. Okay, so you have the corridor and the corridor should be covered by the carpet. Okay, the carpet, they've given you the breadth. We need to find the length. For every 1 meter of length, you get paid of 15 rupees. You have to pay 15 rupees for every 1 meter of length. Okay, first you need to find the length and then find the rupees. Okay, first you need to compare it. Area of carpet, area of the floor. Area of floor equals to area of carpet. Okay, what is area of floor? Same, length and breadth, because both of them are rectangle here. So length and breadth, 100-meter long, 100-meter long, 3-meter wide. Fine. We don't know the length of the carpet. Length, let's have it L itself. The width or breadth is 50 centimeter. Everything is meter here. I want to convert that 50 centimeter in terms of meter. 50 by 100. Can I tell? Okay. So this becomes 1 by 2. This 2 goes there. So L is equal to 200, 200 into 3, 600. So 600 meter of length is required. For every 1 meter, you are paying 15 rupees. Okay. So cost is equal to length into 15. Okay. 600 into 15 will be the answer. That is, you have to pay 9,000 rupees. You get it? You have the floor, you have the carpet, you have to fill the floor with the carpet. So each area should be equal. Area of the floor and area of the carpet should be equal because they are covering. Okay, area of the floor is given, area of the carpet they didn't give you particularly because they've given you only breadth in terms of centimeter. You convert that in terms of meter, half a meter. Bring this there, you get L is equal to 600. Length we found out. They said for every meter of carpet you pay 15 rupees. Right? So you have to get 600 meters. For 600 meters you have to pay 15 rupees. 15 into 15, 15 to 600. 600 into 15 you get the answer 9,000. Okay. 10th question. The radius of the circular wheel is 1.75 meter. The number of revolutions it will take traveling 11 kilometers. Okay, I told you no. One revolution is equal to some distance covered. So total distance covered is equal to n times of revolutions. Okay. So the formula is distance covered equals to n times of revolutions. Revolutions or circumference. Let's say circumference itself. Why? One revolution is nothing but one circumference, right? We get it. So it is given in terms of kilometer. Let me convert that in terms of meters. 11 kilometer is nothing but 11,000 meters. N we don't know. Pi r square, pi r square. What is r square? R is 1.75 here, right? The radius of circular wheel 1.75 into 1.75. We are going to solve it further. Solve it, tell me the answer. Okay, so 1.75, I can even write it as 22 by 7. That is, so this is for 1000 times and 2 times here. Okay, so this fellow I can cut down. 7 1.75. 7 times 0.25 will be there. Okay. Yeah, 0.25. 0.25 into 2 will be 0.5. 0. N into 0.5 into 1.75 equals to 1000. Then N is equal to 1000 divided by 0.5. I can write it as 1 by 2. 1.75. If I double it, I'll get 3.5. Again double it, I'll get 7. I can write it as 7 by 4. Okay. Oh, circumference. I use pi r squared. I'm sorry. It will be different then. N into 2 pi r. 2 into pi into r. R is 1.75. We can easily find it later. So this is for 2 times, and this is for 0.2 times, 25 times. 0.25 into 4, it will be n. N into 2.25 into 2 into 2. So 0.25 into 4 will be 1. N is equal to 1000. I'm sorry. I used area value. That's what I'm thinking. I've got decimal, no? So this is how we get it. So this is very important. Distance covered is in terms of meters. Here also it has to be in terms, it is given in terms of meter, no problem. So n into 2 pi r, circumference, 2 into 22 by 7 into r value is 1.75. Cutting them out 0.25, already 2 into 2, 4 times of 0.5, 0.25, it will be 1. Solving them, you get the answer. Okay. All right. 10th question. I believe we have solved in permutation, sorry, not permutation, percentage in this question, same question. A gardener increased the area of a rectangular garden by increasing its length by 40%, decreasing its width by 20%. The area of the new garden will be, it is increased by 12%. I believe we have solved it. Still we'll solve it. We'll solve it now. Okay. So question 12, sorry 11. Let's imagine length is equal to 100, breadth is equal to 100 itself. Not a big deal. We'll have it. Length is equal to 100, breadth is equal to 100 itself. Okay, so what is the area? Actual area would be length into breadth. It will be 100 into 100, 10,000. Now new area, so new length 1 is increased by, the new length is increased by 40%. It is increased by 40%, then it becomes 140. Breadth is decreased by how much? 20%, then it becomes 80. Correct? So for now, let me imagine length and breadth to be 100 because we are dealing with percentage, no? So to reduce the confusion, I'm doing like this. Okay, so area will be 10,000. Here length is increased by 40%, breadth is decreased by 80%. Then what will be the value then? Area 1. Area 1 is equal to length 1 times of breadth 1. Okay, 140 into 80. 14 times of 80, 18 is 112. 112,000. So from this area to area 1. So area 1 to actual area to area 1, new area. What is the increment? Increment is 1200 increment from what? 10,000. Multiply by 100. You get the percentage content 0000. 12% increased. That's it. Simple process, no? From one number to other number, how much increase? 1,000 and 12,000, 1,200. From where? From 10,000. 1,200 increase from 10,000. What is the percentage? Multiply by 100, you get the fraction. Multiply by 100, you get 12%. So the value is increased by 12%. Okay. And 11th one, it's somewhat like differentiation integration process. So calculus process, but still let me tell you the theorem, not theorem, the result straight away. Whenever you have the rectangle, okay, rectangle you're going to convert that rectangle with some values, okay, or even like this. Rectangle is given with perimeter. You want to find the highest area, okay, highest area will be given to square. Okay, so highest area will be given to area square. Suppose rectangle is given with respect to area. Rectangle is given with the area. So least perimeter will be again square. In your 12th standard differential equations, you would have learnt it to derive some like maxima minima content. I don't want it. All I want is this conclusion only, ultimate conclusion. What is that? If the rectangle is given with perimeter, highest area will be given to square. How do I define it? So perimeter should be equal. So we need to consider that as 4a. Solving them, you get 1. So this rectangle should be considered as square. However way, it has to be considered as square always. Okay. Similarly, if the rectangle is given with area, you need to consider that a square, because you're going to convert that in terms of square, and then you need to find the least perimeter. Okay. A rectangle is given, highest area or least perimeter will be gone to square. Okay, for this case, look at the question. An agricultural field in the form of rectangle having length x1 meters and breadth x2 meters. Okay, x1 x2 are variable. If x1 plus x2 is equal to 40 meters, then the area of the agricultural field will not exceed which one of these following values? Okay, that means you need to find the highest possible area. That is, you need to find a value. Okay, that should be the highest value, whereas other values, other areas will not exceed the particular value which you found out. Okay, that means you need to find the highest value. Here you need to find the highest area. What is highest area? It has to be the area of the square by considering the field to be square. Okay, here they said x1 plus x2. Okay, they said like this. Question number 12. Question 12. They've given you the rectangular field x1 and x2. Let's say like this. Also they've given that x1 plus x2 equals to 40. But I said whenever you're considering whenever you need to find the highest area possible, you need to consider that as a square. If it is a square, x1 x2, they should be equal, no? X1 plus x2 should be equal. Okay, so that's x1 plus x2 equals to 40 by 2, or even I can write it as 20 itself. Can I write it? Because x1 plus x2, that should be equal. X1 plus x2 is equal to 40 means 20 plus 20 will be 40. X1 is equal to 40. Then I want to find the area. Area, that is highest area or maximum area. Maximum area is equal to x1 square or x2 square or x2 square, whatever it is, we get the same answer. That is 400. So 400 centimeter square or meter square, whatever it is. Oh, I'm sorry, this question number 11. Okay. Meter square. The answer is 400 meters square, always. Question 11, this is how we solve. Okay, so it's based on the result we have learned like this. Whenever rectangle is given, we need to find the area. The maximum area means we have to consider that as square. Similarly, whenever they've given you rectangle with area, you need to consider them as square to find the least perimeter. Okay, so that's how we solve the 11th question. How did you consider finding the highest square area? See, what is the question? Then the area of the agricultural field will not exceed. Will not exceed means you can find any other value which is less than that. Whatever the value, if it is less than 400, then 400 is the highest value, no? That's how I found out. Which will not exceed, they said. So that means that I need to find the highest possible value. You get it? Zero, 1, 3, 2. Could you understand? Okay, 12th question. 12 equal squares are placed to fit in a rectangle whose diagonal is 5 centimeter. There are 3 rows containing 4 squares each. No gaps are left between adjacent squares. What is the each square? Okay. Yeah. So most of you found out. Let me tell you that. Question 12, it's like this. You have a rectangular field. Okay. 1, 2. So you've got this. We don't know the area of the square. So let's take the side of square to be x. Let's take one side of a square. This is x, one side of a square. So obviously this is another same square. All the squares are equal, right? 12 sides, 12 squares with there is no space between them. X, totally 3x would be there. Here x, 4x would be there. Whereas this value is given 5, right? So this is 3x, this is 4x. I can tell like this, 3x and 4x. From this I can tell using Pythagoras theorem. What is that? So 4x squared plus 3x squared, a square plus b square will give you 5 square, correct? Right? What is 4x square? 4x whole square, 3x whole square. 16x square plus 9x square is equal to 25. From this I can tell 25x square equals to 25. From this again x square is equal to 1. I want to find area of the square. What is area of square? If x is a side, area of square will be x square. So area of each square is x square. Okay, how did I find it? Very simple. In this area, I am focusing on only one square, whereas one square's area is x squared because I'm considering side to be x. So side is x. So if side is x, what is the area? X square. That will give you the area of x, area of square. So that's equal to area of square. Okay, you understand? So this will give you the 4 times of value, 3 times of value. 4x square plus 3x whole square equals to the diagonal value using Pythagoras theorem, pi square. Okay, solving them, you get the answer. How did I get pi square? This is my rectangle, this is my diagonal, right? They said you diagonals. Okay, diagonal value is 5 meter or 5 centimeter. 5 centimeter, right? So in a rectangle, if you have diameter, we can use, sorry, diagonal, we can use Pythagoras theorem. A square plus b square will give you 5 square. Here a square is 3x whole square, b square is 4x whole square. That's what we given. 4x whole square plus 3x whole square is equal to diagonal square. Pythagoras theorem. So if you have it like this, a, b, c, I can tell c square is equal to a square plus b square. That's how we get it. This is the formula. Pythagoras theorem. Pythagoras theorem, whatever. Pythagoras theorem or Pythagoras theorem. Okay, all right. And 13th question, you can easily find out. You think of a proper number. Okay, they are integers, they said, right? You can tell me the answer. What is the answer then for the 13th question? A square is divided into 4 rectangles as shown below. Okay, we'll check on it. The lengths of the sides of a rectangle are natural numbers. Okay. The areas of the 2 rectangles are indicated in the figure. What is the length of each side of a square? Very good, very good. Siddharth, yes, right answer. Hope you are done with this. Let's go to 12th one. They said 13th one. We have a square. Okay. And you have this kind of area. It is 15. This is 40, they said. Okay. So 15 means it has to be, they are all natural numbers. There are no decimal values also. Natural numbers means which one will give you 15? 3 times of 5. So the lengthiest part, let me take it as 5. So this is 5, this will be 3. Can I tell? This is 5, this will be 3. Okay. So in that case, you might have it like this. I'm taking the lengthiest part to be 5 and the smaller part would be 3. And similarly here 48. 48 means which, I mean, there are two numbers 68 or 86. Both will give you the 48 because they are all natural numbers. 6 or 8 or natural numbers. 6 or 8. Okay. So 6 times of 8 will be natural numbers. Smaller side, let me take that as 6. Larger side, let me take that as 8. So let me take it as 6 here. Okay. So in that case, so 5 will come here, 8 will go there. What is the length altogether? It is 11 here. It is 11 here. So 11, obviously it is justified. The side of a square, then side of a square. Side of a square is 11 centimeter. No, 11 units. That's it. Whatever it is 11. How did I get it? Very simple. I just consider the proper natural numbers to get me 15. What is 15? 3 times of 5. So I'm considering the bigger side to be 5, smaller side to be 3. That's usual. That's easy, right? By looking at the picture itself, I can find it. Similarly, 48 is there. Natural number 6 times of 8 or 8 times of 6 or 12 times of 4, 4 times of 12. That's also possible. But still, 6 and 8 will be, no, that will give you the justifiable answer because the lengths are little bit nearby. Okay. So you can tell like this. So here 6 and here 8. That's how we get it. If it is not natural number, how can we solve the same problem? If it is not a natural number, then the data invalid. Simple, right? You cannot justify the value. It can be any natural number or any decimal value also. So if it is a decimal number, you've got plenty of other ideas. So one student will get 10, other student will get 12.5, other one will get 12.9, 13.2 or 9.5, whatever it is. Plenty of other answers will come. So then we can tell data invalid, right? That's all. For 15, can we ignore 1 into 15 possibility? Yes. Why 1 into 15 possibility? Let me tell you. This is a rectangle. Okay. By looking at the picture, let's say like this. So let's say this is 5 centimeter. Can it be 1 centimeter? No. Can it be 5 centimeter? No. It's a rectangle. Hence, it cannot be the same side. If it is a square, then it is 5. It is a rectangle, then it is not 5. It can be less than 5. It can be 4.9, 4.8 until 0, until 1, 0.1. But by looking at this length, so this length, if it is here, it will be approximately this side, this length. So if this 5 is here, it will be approximately 5 here. So more or less it will be 3 or 3.5. Can I tell? Approximately, judging by the picture. That's what I'm doing here. By looking at the picture, I'm judging the values. Simple. Yes, you can use that also, but check with the values. So what is 44? Let's say like this. See, you have one value. Let's take this is 48, no? So let's take 4 here, 12 here. 12 4s are 48. Okay. So it will be 4 come. You will get 4. 5 plus 4 will be 9. Then this becomes 12. 3 plus 12 will be 15. So here 9, here 15. Is it possible to get a square like that? 9 one side, other side it is 15. That's highly impossible. Correct? That's how we solve. That's how we'll eliminate this 4 into 12 and 12 into 4. So we'll have to go with the smaller number. Why did I go with smaller number straight away? Look at the picture. If this is one length, the other length should be little lesser than that, not the bigger difference. 12 is one side, 4 is other side. So the difference will be 8. So larger part. By looking at the picture, I cannot judge like that, right? That's how I solve like that. So here it will be 6. it will be 6, it will be 8, hence it will be 6, it will be 8, always. Then only you will get a square, because the given in the question it is given that it is a square. It is not a rectangle, it is a square altogether combined. You understand? Okay. All right. So we shall go to the next part. Okay. So that's three-dimensional way, because we call it as volumes and surface areas. We'll solve them. We'll solve the ideas. Okay. So let me give you the formula first, and after break we shall solve the questions. So let's go to the content. Okay. Three-dimensional space, three-dimensional way of looking out for the square. Okay. So you have a square. Its three-dimensional way of looking out is called as cube. Okay. Whose side is A. For this case we need to have three values or three other formulas. Okay, so three values. First value is lateral surface area. Okay, what is lateral surface area? This is volume. Okay, volumes and surface areas, three-dimensional area. And always remember, for 2D figures you will deal with perimeter or circumference and area. For 3D figures you will deal with lateral surface area or curved surface area, total surface area and volume. So lateral surface area, I'll write it here for now. Lateral surface area, total surface area. But I'll do one thing. I'll give you the generalized formula first, or like decoded generalized formula. Based on that, we shall derive the formulas. We'll do one thing. Let's leave this for now. I want to find the lateral surface area, LSA or CSA. LSA or CSA. Then total surface area, then volume. Okay, I'm going to give you the generalized formula. There are two varieties of the figures. Prism, pyramid. Okay, there are two varieties of figures. Okay, one is prism, other one is pyramid. Prism means I can call it as I can give you an example, kaleidoscope. Okay, kaleidoscope will be there. So that kaleidoscope you can easily find surfaces, right? Or even a different variety of kaleidoscope. I can call it as cylinder. Can I use cylinder? Okay, kaleidoscope you would have seen it as a rectangular space inside it, right? No, triangular space inside it. But what if it has, what if it has the cylindrical space like this? In that case, or even what if it has a cubical space like this? You may get it. What if you have like that, you can solve questions like this. I'll tell you how to solve it. Pyramid, only one example is there for now. Okay, for your exam point of view, you'll deal with only one example, cone, conical space, only cone. Other spaces would have gone. And a sphere, hemisphere, that is different variety. We don't want to deal with that for now. So these two can be compared. Okay, how do I take LSA? How do I find LSA? First, let me tell you one thing. Let's take a cylinder. Okay, yeah, this is fine. Let's take a cylinder. Let's take cylinder alone. I want to find lateral surface area. So this is my cylinder. I want to find lateral surface area. That means I'm painting the sides alone. Okay, I'm painting this sides alone. So if I paint this side, very simple, I'm leaving the top and bottom areas. Okay, I'm painting this side alone. So let's do one thing. I'm putting one line here. Okay, other line here, other line. So completely lines. If I draw lines inch by inch, I'll completely paint it, right? Eventually, I'll do it slower, but still eventually I'll paint the whole area, right? This is what we call lateral surface area. I'm painting the sides. Okay, I'm drawing lines on the sides. So this line, no, this one line is nothing but this area, not area actually, this perimeter. Okay, so whenever you have it like this, that's different. Okay, whenever you want to find lateral surface area, always remember base perimeter or base circumference. Base perimeter, this base perimeter, no, you're doing for this many times. What is this actually? Height into height. That's what we call lateral surface area. So this is my lateral surface area. What is total surface area? You will paint top and bottom also. What is top and bottom? We have got circle here for the case of cylinder. Okay, so base is one area, other one is other, top is other, again one more area. So both of them will be equal. In that case, I can tell lateral surface area plus base areas, base area, and it will be the same thing, lateral surface area plus base area. But for this case, it will be different. I'll tell you later. Okay, here volume. Volume is quite simple. Let's imagine a cylindrical cup, let's say cylindrical cup or cylindrical tumbler. Okay, so if you fill one layer of the tumbler, that means it's a area, correct? So you have the cylindrical tumbler, you're filling one layer, that is this one layer. This is nothing but area covered by the water of the glass, which is circle or area of the base. Okay, this kind of water will be filled until this, until up to the brim. Up to the brim means it is completely filled until this side. Okay, this side is nothing but height. Okay, this area of the water is filled until the height up to the brim. So I can tell straight away like this, base area multiplied by height. Simple. So these three, remember. From this you can derive. How do I derive? See, prism to pyramid, it's a half of the space in terms of area. Okay, in terms of area, half of the ratio. So it will be 2 times, it will be 1 time. That means half of the ratio. Half of base perimeter, not actually base perimeter, I can tell. So, okay, let's take base perimeter itself, we'll solve. Base perimeter, let's say base PM, perimeter means PM, let's say now. So half of the base perimeter, here you do have straight height, prism, no, you have slant height, multiplied by slant height, slant height. Always remember this. Okay, and here it will be the same thing. So LSA plus base area. Okay, here if you might have two areas also, so two area or areas. So here same base into height. Oh, it should be base area into height. Okay, base area into height. In the case of volume, we have a theorem. Whenever I compare prism and pyramid, in the case of volume, this will be 1/3. If it is 3 times, it will be 1 time. So I can write it 1/3. This is my generalized decoder formula. With the use of this, you can create formulas. Okay. We'll derive the formulas now. We'll do it faster, and we can find the answers easily after the break. Okay. So first we'll derive the formula. Copy them faster. Prism, solid, prism and pyramid, both of them solid. In your syllabus, it is always solid, maximum solid. Okay, 99.99% in your syllabus, it is always solid, not hollow. So don't confuse with them. Yes, Anju, right answer. Right. Your idea was right. All right. Shall we go there? Right. So let me give you the formula. Let's derive the formula for cube, cuboid, cylinder, and so on. Okay. First, cube. LSA, lateral surface area. You have only one side, right? So cube is all the sides are equal. Only one length will be given A. Okay, that A will be common for all the sides. What is the formula for LSA? Base perimeter into height. What is base perimeter? A plus A plus A plus A. 4A va? 4A into height. Height is A here. So length A, breadth A, height to A. So base perimeter is 4A. 4A into A. That is 4A into A equals to 4A square. And total surface area. What is total surface area? Base perimeter plus LSA plus top and bottom areas, base areas. Here you have got one base area there, top area, base area, bottom area. Top area is 1 square, A square. Bottom area is another square, A square. So 6A square, 2A square, altogether 6A square. Or I can also tell you an example of a cubicle room. Okay, you want to paint. Say for example, you want to paint, except the ceiling. Obviously, you will not paint the floor. Okay, you will paint side, lateral surface area. You paint laterally. You're painting laterally means you're painting lateral sides, 4A square. If you want to paint and then design the top and bottom also, mean the ceiling and the floor also, you're covering the complete part. Okay, total surface area, lateral surface area plus top area plus bottom area. So two area, at the top you'll have A square, at the bottom you'll have A square because it is a cubical unit, right? And then volume is quite simple. Base area A square into height A square into A, hence you get A cube. That's it. This is for cube. What if you get a cuboid? Let's imagine like this. Random. So length, breadth, height. Let's imagine like this. So what is the LSA, lateral surface area? Base perimeter 2 times of length plus breadth into height. I can write it like this, 2 times of LB plus BH. Okay, and then total surface area. What is total surface area? Lateral surface area 2 times of LB plus BH multiplied by top and bottom areas. Can I tell? So top and bottom area is this one. Okay, LH. Oh, 1 minute. This is LH plus BH. LH plus BH plus 2 times of bottom area, L into B, 2 times of L into B. So you'll get 2 times of LB plus BH plus LH. LB plus BH plus LH, 2 taken common outside. That's my total surface area. What is volume? Base area, LB into height, LBH. Okay, and certain other formulas are there. You remember that. You have to remember that. I'll tell you. Similar to the diagonal, we had no longest line you can draw in a square or rectangle. That's be diagonal. No. Similarly here, longest rod or longest, let's say, okay, longest rod itself. Longest rod that can be placed in a cubicle box or cubicle room would be the diagonal like this. See, if it is this diagonal, that's not a big deal. So let's solve from this. If it is this one, not a big deal. That's a square diagonal. But cubical diagonal would be like this. Okay, so from one corner to the, from front end corner to back end corner, front end bottom corner to back end top corner, remember that. Okay, so front end corner to front end front top corner will be diagonal of a square. I don't want that. All I want is diagonal of a cube. So here let me write diagonal of a cube is equal to, okay, root of 3a square, a root 3, you will get the answer like this, a root 3. Here similar diagonally from diagonal from this space to this space, lengthiest rod, longest rod that can be placed in a cuboidal space or cuboidal room, that will be d equals to root of diagonals like this, l square plus b square plus h square. That's another formula. Copy them. This is for diagonals. Always remember that, because I believe you got one question based on this idea. I'll tell you. Yes, you've got one question based on this idea. UPSC. Okay. Hope you've copied this. Then let's go to other one. Four other things are there. So we'll deal with the first cylinder. Okay, cylinder with radius r, height h. LSA will be base perimeter 2 pi r into height 2 pi r h. TSA will be LSA plus base areas. Bottom area will be pi r square, top area will be pi r square. So 2 pi r square. Hence it will be 2 pi r 2 pi r h. 1 minute. 2 pi r h plus 2 pi r square. I have taken 2 pi r common outside, so I'll get 2 pi r into h plus r, and then volume. Volume will be pi r square, that's the base area, into height pi r square h. Okay, and for the cone now, similar process, but here we need to understand one simple idea. Cone is there, no? So for the cone, we need to have L, lateral height, because slant height is given, no, lateral height, and height will be given, that is h. This is radius, this is h. So from this I can tell length is equal to, slant height is equal to height square plus radius square. Okay, so I will tell lateral surface area, what was that, 1 by 2 into base area 2 pi, base perimeter 2 pi r into slant height L here. So 2 gets cancelled, you will get pi r L. Total surface area pi r L plus base area. We don't have any base area at the top. We don't have any area at the top. It will be a simple dot. It will not cover any area. But here it will cover a circular portion. Circular portion means pi r square. That's the area of the base, right? So pi r taken common outside, L plus r will be the ultimate content. And then this fellow, volume. Volume is very simple. 1/3 of pi r square into h. Height will be given. Okay. 1/3 of pi r square h. That's it. So this is the formula for basic prism and prism pyramid. And last two are there, sphere and hemisphere. We shall solve, we shall write that also, and we'll go for break. Okay. Okay. Last two. I'll go there. Sphere with radius r, hemisphere with radius r. Okay. So we have lateral surface area. Here we call them as curved surface area. Why curved surface area? We don't have any corner at all here. For the For this case also we can call curved surface area, not little surface area. Curved surface area, curved surface area. Okay, so because we don't have any corner, we have circular edges we have, but corner, sharp corners we don't have. But here we have sharp corners. Okay, but here we don't have it, and here still we don't have it. For the case of sphere, what is the formula? That's exclusive formula. CSA of sphere is 4 pi r square. Obviously TSA, they are equal. TSA equals to CSA. Okay, TSA, they are equal to CSA. Hence again we can call it as pi r square. Volume 4 by 3 pi r square, pi r cube, I'm sorry, 4 by 3 pi r cube. That's the formula for sphere. Hemisphere, CSA will be 4 pi r square, so I'm sorry, not that, 2 pi r square, half of that, 2 pi r square. TSA will be, see, 2 pi r square is nothing but the circular portion of that. Okay, but total surface area means you need to cover the top area also. Top area means we have got one other pi r square at the top. Okay, you will get 3 pi r square. Okay, and then volume is equal to half of that, 2/3 of pi r square, pi r cube, I'm sorry. That's it. Yes, Siddharth, right. LSA plus 2 base area. No, we have got only one base area. That's why I've given you base areas for the prism, and pyramid we have got only base area. Base areas, I've written S in the bracket. Did I write 2 times of base areas? Only base area only. Base area or base areas. Here only one base area. Okay, and then some unit conversion are there. I'll tell you. With that, we'll just give you the break. Just 1 minute. Okay. Hope you're done. Always remember this. 1 meter cube, that's equal to 1 meter into 1 meter into 1 meter. Okay, a cubical space of 1 meters will contain 1000 liters of water or 1000 liters of liquid or 1000 liters of space. It will contain 1000 liters of space. Similarly, 1 centimeter cube, okay, 1 centimeter into 1 centimeter into 1 centimeter, it will contain 1 liter. Okay, no, 1 by 1000 liters, I'm sorry, 1 by 1000 liters. Okay, 1 decimeter cube will contain 1 liter. Fine, that's not a big deal. So we need to understand these two. And 1 meter cube or 1 meter square, first we'll deal with 1 meter cube. No, 1 meter square, 1 meter into 1 meter, no, that's again I can call it as 100 centimeter into 100 centimeter. On that, that's equal to 10,000 centimeter square. Okay, 1 meter square is equal to 10,000 centimeter square. Always remember. Similarly, I can tell 1 meter cube equals to 100,000,000 centimeter cube. So for meter square, 4 zeros. For centimeter meter cube, 6 zeros. Because 1 meter equals to 100 centimeter. Okay, va? For 1 meter, just meter power 1. For power 1, 2 zeros. Power 2, 2 zeros square, 4 zeros. Power 3, 2 zeros cube, 6 zeros. That's how we get it. Okay, we need to understand this conversation. Conversion, not conversation. Conversion. So once you understand this conversion, that will be easier to find the answer whenever some liters and grams, kilograms are given. Okay, remember this. We know it is 1 decimeter. We learned it, no? 1 decimeter is equal to 10 centimeter. Okay, that's not a big deal. We have learned just before. These things are big deal. We need to understand this. And now you can go for break. Be back by 11:20. No, 11:25. Let's take 11:02 now. No, so take 23 minutes break. 11, 20, 25. We shall complete the question within 1 hour. That's easy only. Okay. So copy them, and I'll just tell you, I'll show you the generalized part. This will be here. Show circle and semicircle formula. Circle, semicircle. Is it sphere, hemisphere, or circle, semicircle at the beginning? This one. Is it? Or sphere, hemisphere? This one? You mean sphere? Okay, okay. Go ahead, this one. Others, you can go for break. Be back by 11:25.
Recording stopped.
Number 168. Question number 1. Okay, so these are all very silly questions, and always remember, you have to look at the question and check whether they are asking about this lateral surface area, total surface area, or volume. Okay, always remember, whenever they compare two different shapes, whenever they compare like a cylinder to cube, cuboid to cube, or cuboid to cylinder, or cylinder to cone, sphere to cone, whatever it is, whenever they compare, they reshape, you always do with terms of volume. Okay, you have to solve in terms of volume. That's it. Okay, we'll solve. By the time we'll solve, we'll understand it. The dimensions of the cuboid are in the ratio 1:2:3. Its total surface area is 8 meter squared. The volume is, so we need to find length, breadth, height, and then volume. Okay, so length, breadth, height, they are in the ratio 1:2:3. That's what they've given, right? So I can tell that length is equal to 1x, breadth is equal to 2x, and height is equal to 3x. They said the total surface area is 88 meter squared. I can use it, right? So what is the formula? Total surface area let's use it here. LB plus BH plus LH, no? 2 times of LB. What is LB? Now I'll write it here. 2 times of LB plus BH plus LH is equal to 88. Okay, bam. So what is LB? 2x squared plus BH 6x squared plus LH 3x squared equals to 88. Okay, so 2, this one 44 times, and this fellow added together 11x square is equal to 44. From this I can tell x is equal to 2. How? So this is for 4 times, so x square is equal to 4, x is equal to, always remember the values, they're all measurements, lengths, right? So the value will be positive always, right? So x is equal to 2, and hence I want to find volume. Okay, volume is equal to L into B into H. So L is equal to x, B is equal to 2x, and H is equal to 3x. Okay, or even we'll find the values and then solve it. So what is the values? So this one will become 2, this becomes 4, this becomes 6, correct? So x, 2x, 3x, then 2 into 4 into 6. What is the value? 6 4s are 24, 24, 48. 48 centimeter cube or meter cube. Here it is meter cube, right? No, centimeter cube. 48. Option C. Okay. All right. Now comes next question. A sphere of diameter 6 centimeters dropped into a right circular cylindrical vessel partly filled with water. The diameter of the cylindrical vessel is 12 centimeter. The sphere is completely submerged in the water. What, by how much will the level of water rise in the cylindrical vessel? Okay. So we'll do this in diagram. Okay, first copy this faster. What did I do here? I just had the ratio like this, x is, so instead of the ratio I'm using the values in terms of x, and I used the formula of total surface area. I found the value of x. From that I found the length into breadth, height, the values of length plus height. Hence I found the volume, right? And now it is given that in a cylindrical vessel, second question, in a cylindrical vessel whose radius is 12 centimeter, a sphere of radius 6 centimeter is dropped. It is completely submerged. Actually at the beginning we had a water until this place, okay, partially filled with water. Now let's imagine half of the water is filled, okay, at the beginning, before you put this sphere inside the cylindrical vessel. Okay, due to the Archimedes principle, what will happen? The volume of the sphere will reflect on increase in volume of the water, correct? When the volume of water increases, what will happen? The height in the vessel will increase, yes or no? Correct? You understand, no? So very simple, the height in the vessel, so it will at least it will increase until this space, let's imagine. So this one, until this space the height has increased. Let's say this is height, let's say that's height. Okay, so let's take H. Now very simple, volume of cylinder equals to volume of sphere. Why? Due to Archimedes principle. How do I tell? When the sphere is inside, it will just push, it will push extra value. Okay, it will give you extra value in the sense it will be equivalent to the volume of its own, right? Volume of the water, volume of equals to volume of the cylinder. Here volume of water will acquire the shape of the cylinder, correct? That's why I used volume of the cylinder. Here I don't know the height, I want to find this height only because the water has got raised, right? The raised height is what I want to find. Okay, so pi, what is the cylinder formula? Pi r square h. Okay, here volume of 4 by 3 pi r cube. Let me use some other r because two r should be different, right? So pi gets cancelled, not a big deal. What is r here? 12. 12 into 12 into h equals to 4 by 3 into r cube. What is r cube? 6 into 6 into 6. 6 into 6 into 6. Okay, this is for 3 times. Can I tell? Right. And then this is for 2 times. This is for 2 times. 2 get cut. Okay, I'll bring this 3 here, I'll get 6 by 3, hence the value becomes 2 centimeter or meter. In the question it is 2 centimeter. You understand? Is it diameter? Oh, diameter, I'm sorry. Then it should be 6, it should be 3. Okay, fine, no problem. The same formula will happen, the same value will happen. So here it is 6, it will be 3. Okay, so what is the value of cylinder? 6 into height. Here it is 4 by 3 times of 3 into 3 into 3, right? So 3 gets cancelled, 3 2 times. No, better I'll do one thing. I'll bring these values here. H is equal to 4 into 3 into 3 by 6 into 6. Okay. Yeah. So 36, 1 centimeter. Who's that? Yeah, Siddharth. For the first question, the option units were wrong. It is meter squared. In the second question, diameter 6 centimeter and vessel diameter 12 centimeter. So it is 6, it is 3. Solving them, the answer becomes 1 centimeter. Okay. So 6 into 6 into h is equal to 4 by 3 into 3 into 3 into 3. So that is 36, 36. Cut down, you get 1 centimeter. Yes. They've given diameter 12 radius. Yes, Narmata, right answer. Right. All right. Third question, a wooden box measures thickness of wood is 1 centimeter. Volume of the wood to make the boxes. Oh, okay. So this is your answer. So let's go to the third question. Third is little tricky. You have to understand in a silly way. You have the wooden box. No. Let's. You have the wooden box. They have the measurement of cuboid. Okay, and the width, thickness of the wood is. So thickness of wood would be it'll be like this. Right. So this would be the thickness. Thickness is 1 centimeter, 1 meter, 1 centimeter. So this would be the thickness. So this is hollow, right? So they said you want to create a wooden box. Okay. So whereas thickness is 1 centimeter. Okay. So in that case, just look at the top point of view. So you will have this top space. Okay. You look at the if you look from the top, you have this rectangular part or the top. Okay. So this top, if you have the thickness, it is 1, it will be like this. In this inside part, it will be empty space. But this is what the wood. Okay, we have the wood, right? So what could be the volume of this complete figure? Very simple. The outer figure's volume minus inner figure volume. It's somewhat like you're taking a scoop of ice cream from a box of ice cream. Okay, so have you been into receptions of no, in Tamil Nadu weddings? No, you've seen that. In the reception, they would give you the ice cream. They'll take the scoop from a cubical box. They'll take a scoop. Similarly, from a cuboidal box, you take cuboidal scoop outside. From a solid bigger box, you take solid part outside. Okay, how do I get it? I can tell volume of box equals to volume 1 minus volume 2. What is volume 1? Volume 1 is outer area volume. So outer areas, they've given you the values 20, 12, 10. So that's your value 20 into 12 into 10. So let's say this is your 20, this is 12. Let's imagine 20 and 12. Okay, what is the inner part? It would be 1. Okay, the thickness is 1, right? Okay, 1 gone, 1 gone. What will happen? It will be 18, minus 18, 18, this area. This area will be 18, correct? And then this area, 12 minus 2, that will be 10 multiplied by 10 minus 2, that will be 8. Could you get it? You understand? Okay, thickness is taken out. I'll draw that again. You have got a cuboidal box, whereas you have to form it using a thickness of 1 centimeter, using the top view. Okay, so this is 1, this is 1. Out of this 20, 1 meter thickness, 1 centimeter thickness, 1 centimeter thickness out are taken away. This length, no, this length, that length would be out of 20, 1 taken away, that will be 18. Similarly, 10 there, 8 there. Okay, in that scenario, solve them, get me the answer. 20 into 12, it will be 240, 2400, minus 18 8 sir, 64 or 8, yeah, 144, 14400, 1440. Okay, so 1400, 2400, 100, 1000 will be there, 1000 minus 40, 960. Do we have option? Yeah, we have it. Option A, 960 centimeter square. It has to be cubic centimeter cube, I'm sorry, cubic centimeter, na? That's how we get it. Okay. Okay. Simple. If the radius of the right circular cylinder is decreased by 50% and the height is increased by 60%, its volume will be decreased by. Okay. Does the height also change? Yeah. See, here everywhere it will change, right? 1 meter thickness. So even though it is hollow in the inside, top also you'll get, right? So in the top you'll have the thickness. So let's take a cardboard box. In the cardboard box, top also will have thickness. It will not be empty, right? That's how we get it. We have to do the fourth one. Yes, I'm sorry. We'll solve the fourth one. The volume of a conical tent is 1232 cubic meter, so meter cube. The area of the base is 154 meter squared. Find the length of the canvas required to build the build the tent. If the canvas is 2 meter width, conical tent, so cone, we need to solve it like this. So question 4, Suresh, you get it? Whatever I told, could you understand? Question 4, conical tent is there. They've given you the volume and the base area. First we'll deal with the base area, then only we can find radius. Okay, what is the base area here? Circle. Circle's area is pi r square. So pi r square equals to 154, they said. Okay, from this I can find radius. R square equals to 154. This is 7 times. Hence r square is equal to 7 into 7. From this I can tell r is equal to 7. Okay, done. From this I know how to find volume also. Okay, but still volume is given as 1232. Yeah, 1232. Volume 1232. What is the volume? 1 by 3 pi r square h equals to 1232. But I know the value of pi r square. 154, no? I'm going to use that. Okay, 1/3 of 154 times of h is equal to 1232. Right? So 1232. I don't want this now for now. So 1232, I can bring it here. 154, 1232. Into 18. 154 and 8 will give you 1232. So 4 8s are 32. 3, 2, 3, 8, 5 of 40, 8, yes, correct. Right? So bring it there, h is equal to 24. You've got h and r. You're going to form a tent. Okay. How do I define the tent? To create a tent, what will happen? You need to understand the curved surface area, because base will not be covered for a tent. Correct? So you're going to use the lateral surface area into area of equals to area of the material. Here the material is canvas, so I can tell area of canvas, area of canvas. Here the canvas is rectangular sheet. Okay, with the use of this rectangular sheet, you're creating a conical tent. Okay, right. Then how many meters of canvas is needed? Whereas the width is given, width is 2-meter width. Yes. What is this length? I don't know. We need to find that. Length into breadth, it will be here. What is the lateral surface area? We need to find LSA, right? LSA means I need to find L. What is L here? First of all, L is nothing but root of h square plus r square. That's what I want to find. So L is equal to root of h square, 24 square plus 7 square. So 24 square plus 7 square, 24 is 576 plus 49. 625, it is 25. L is equal to 25. Okay, if L is 25, I can use it here. What is the formula? Pi r L. Here length into breadth, because L is there. No, I want to use different L. That's why I'm using capital L. So pi 22 by 7, r 7, L value is 25, equals to length. I don't know. That's what I want to find. B is 2. Okay, 7 gets cancelled. This fellow 11 times. So L is equal to 25 into 7, 275 meters. Okay. meters. That's how we get the answer. Don't worry, you'll not get this kind of lengthy question. These are all just practice to understand, to explore more about this topic. Okay, and you have got some UPSC question, and that would be the standard of the question. That's how the questions will be, very silly. Okay, these are all some exploration about the questions. I mean the topic. Question 5. Copy this faster. This is very important. How did you find this? This one, L is equal to root of h square plus r square. Okay. Question 5, 50 centimeter reduce, 50% reduce and 60% increase. All right. For that question, we'll solve, for the 5th question, we'll solve in terms of the basic equation, with the use of the basic equation itself. What was the question? If the radius of the right circular cylinder, okay, first we'll deal with the right circular cylinder. Question 5, volume of cylinder. Let's say V1. V1 to V2, it has got shifted, no? So V1 is pi r square h. And what is V2? Here, pi, there is no difference. R, the radius has got decreased by 50%. So at the beginning I had R. Okay, just radius. It has got reduced by 50%, means 1 R has got reduced to 0.5 R, half of R. Can I tell? Radius has got reduced to 1 by 2 times of R. Can I tell? I'm going to use that. Okay, so 1 by 2 times of R whole square. And height has got increased by 60%. Got increased by 60% means 1.6 H. I'm right there. So 1.6 H, because it is 60% increased from 1. What is 60%? 0.6. It is increased 1.6. That's how we get it. From 1, 50% decreased. 50% means half. From 1, half has decreased means half is there. Half. Okay, I'm going to find the value here. What is the value? Pi r square h. There is no difference with that. Pi r square h. Pi r square h. Okay. What is 1 by 2 square? 1 by 4. What is this value? 1.6. Let's have it as such. So this is nothing but 0.25. Can I tell? No, wait. not 0.25, it's 0.4. 1.6 by 4 is 0.4. Actually, 0.4 pi r square h. Now look at it. Actually, it was 1 pi r square h. Now it has got reduced to 0.4 pi r square h. So volume 1 to volume 2. What is the ratio? From 1 it is reduced to 0.4. How much reduced? 0.6. What is the percentage? 60%. That's it. Okay. 0.6 reduced. Okay. 0.6 reduced in terms of percentage, I can tell 60%. 0.6 multiply by 100, decimal to percentage, you multiply by 100, you get 60%. This is how we solve it. This is what we want. How do I get it? I had this basic formula, and there radius is reduced by 50%, height is increased by 60%. Solving them, I've got the answer. This step, see, pi, that's a constant, leave it. Radius, it has got reduced by 50%. So 1 r has become half of the r, because half reduced, right? So 1 become half. 1 r becomes half of the r, half of r. What is the formula? Pi r square h. So radius square height, pi into radius square into height, that's the formula. Radius square, done. Half of r is the radius, new radius, and whole square, new radius whole square. Then new height, what is the new height? It is increased by 60%, 1.6 height. Okay, now what I'm doing, I'm just writing the variables, I mean the letters alone. Pi, no problem. R square have it. 1.6 leave it, h write it. Okay, what is 1 by 2 square? 1 by 4, and then multiplied by 1.6. That's how I got it. You understand now? Meera? Done. Okay, let's solve the next question then. Question 6. The three metallic spherical ball of radii 3, 4, 5 are melted into a single spherical ball. What is the radiation? Okay, see here, 3 balls you're melting, recasting into a newer ball, bigger ball. Obviously you'll deal with volume. Okay, that's very silly to find the answer. Hope you're done with this. Let's solve the 6th question. It will be like this. 6th question, first ball, second ball, and third ball. You have these 3 balls to be reshaped as a bigger ball. Okay, so let's take the radius, radius 1, radius 2, radius 3, to create a bigger radius. So you have to deal with volumes, right? So volume of the first ball will be 4 by 3 pi r1 cube. Similarly, 4 by 3 pi r2 cube. That's a formula, right? For the sphere, 4 by 3 pi r3 cube. And all together I get 4 by 3 pi bigger r, capital R cube. Okay, so I can take 4 by 3 pi common outside and divide it. 4 by 3 pi I can take and then divide it throughout. So I'll get eventually r1 square, sorry, r1 cube plus r2 cube plus r3 cube equals to r cube, right? What is r1 cube? That's the value, no? 345. So what is 3 cube? 3 cube, this is 3, this is 4, this is 5. What is 3 cube? 27. What is 4 cube? 64. What is 5 cube? 125. That's equal to r cube, right? Adding it out, you get the answer. So 60, 80, 80, 120, 200, 211, 216. So r cube is equal to 216. From this I can tell r is equal to 6 centimeter or meter. 6 centimeter. Centimeter or meter? 6 centimeter. But they didn't give you the unit. So 6 centimeter is the right answer. Okay. So this one you need to remember. That's question 7. Meera, you had 0.6, no? So let me write it here. You had this 0.6 there. 0.6. I want to convert that in terms of percentage. How do I get it? First, let me convert it in terms of fraction. What is 0.6 in terms of fraction? 6 by 10. Whenever you have a fraction, how do I define it in terms of percentage? Multiply by 100. Can I tell? 6 by 10 multiply by 100. 0, 0 cut. You get 60%. This is one method. or from the decimal to straight away percentage, multiply by 100, you get the answer. You multiply by 100, you get the answer. That's it. We got 0.4. Is it? Actually, you had 1. At the beginning, you had 1. After solving it out, you got 0.4. 0.4. How much is reduced from 1 to 0.2 to come to 0.4 from 1? How much is reduced? 0.6 reduced. Okay, in decreased value. From where? From 1. That's the base value. Okay, decreased value, base value, multiply by 100, you get the percentage straight away, 60 percentage. That's the formula. Okay, you used to have the formula, no? Increased value or decreased value by base value into 100. This is one kind of formula. Or even you would have got like this, initial value minus final value by initial value into 100. Same formula. You get it, Meera? Superb. Okay, so let's solve the next question. Like 7th one. What is the 7th one? A cube has surface area 150 square feet. Surface area. Whenever they tell you surface area, always remember it is total surface area. Okay. Question 7. They told you the total surface area of a cube, that is 150. What is total surface area of a cube? 6a square. 6a square is equal to 150. I can cut it down. This is for 25 times. Then a is equal to 5. From this I can tell what is volume. What is volume? Volume is equal to a cube 125 cubic centimeter. Simple. Okay. 8th question. The length of the longest rod that can be placed in a room which is 12 meter long, 9 meter broad and 8 meter high. So 12, 9, 8. Question 8. They ask you to find the length of longest rod. Longest rod means we need to use diagonal value. Okay. Diagonal is equal to root of L square plus B square plus H square. L square, B square, H square. 12, 9, 8. Yeah. 12, 9, 8. 12 square, 9 square, 8 square. That is equal to 144, 81, 64. Okay. So 4, 4, 8, 9, 14, 14, 18, 1. Okay. 2, 289 means 17 centimeter or meter. In the question it is meter. It is meter then. 17 meter. That's how we get the answer. Root of L square plus M square plus L square plus B square plus H square. That's it. Okay. 8th question over. 9th question. The cost of carpeting a room 120. If the width had been 4 meter less, the cost of carpet would have been 20 meter, 20 rupees less. The width of the room is. Okay. 9th question is very silly, but it looks like tricky and lengthy, but you can easily find the answer. I'll tell you how. Okay, hope you are done with 8th. We shall go to 9th question. Yeah, Anju, right answer, I believe. Try to find the next answer. So 9th question. Let's solve 9th question. They said carpeting a room. So let's with this had the width been 4 meter less. So that means width is given. Width is reduced. So they are dealing about width. That means length also should be there. They didn't tell you about cube. They said it is nothing but a cuboid. Cuboid means length and breadth. So we'll deal with the length and breadth. Cost of carpeting a room, 9th one, we are dealing with rectangle now. Okay, no square, just rectangle. Okay, because width is given. Width is somewhere else it is discussed. When you discuss width, obviously length should be there. Length we don't have, but still we'll have it. So you have length and breadth. Let's imagine length and breadth will give you area, and you carpet it. Carpet means you need to cover the area. Okay, that is costing rupees 120, right? So let's say you are covering 1 meter area means you get 1 rupee. Let's imagine like that. When you cover 1 meter square area, you get 1 rupee. So 120 meter square area, if you cover that, you will get 120 rupees. Correct? So let's imagine like that. So length into breadth will give you 120. If you cover length and breadth together, it will get It will get you 120 rupees or 120 square meters. For each square meter you are getting 1 rupee, hence you get 120 rupees. Now it is given that if 4 meter less in breadth or width, if you reduce, if the breadth is or width is reduced by 4 meter, the total cost you got will be reduced by 20 rupees. So it would become 100 rupees. Yes or no? That's my equation number 2. Yes or no? Find the width of room. That's what they've asked, right? They ask you like this: length into breadth into some rupees. Okay, length into breadth into some rupees per unit meter square. You get 120 rupees. Okay, similarly, if the width is reduced by 4 meter, your total cost you get will be reduced by 20 rupees, right? That's how we get it. Now I want to find B, not L. I can do one thing: divide these two equations. Can I? Simple. 1 divided by 2. First equation divided by second equation. Very simple. LB divided by L into B minus 4 equals to 120 by 100. 120 by 100 in terms of 20 table. This is for 6 times, this is for 5 times, and L get cancelled. Do cross multiplication, you get the answer. 5B equals to 6B minus 24. 6 4s are 24, no? So bring this B here, 24 there. So 24 is equal to 6B minus 5B. From this I can tell B is equal to 24 meters. That's it. You understand? That's how we get it. Simple. Okay. This one, decoding these two equations is very important. Because you're considering length and breadth would be given. Let's say you're going to find that, and still they told you about this rupees. They didn't tell you about the area. So whenever you cover some area, you get some rupees. It can be any amount, but still we are imagining 1 rupee is the amount you're getting for 1 square meter area. 120 rupees you got means you completely carpeted 120 square meters of area. Likewise, let's imagine like that. We'll solve it. We'll get the same answer. Okay. 10th, I don't know this. Anju, I'll check with that. I believe, yeah, the right answer, I believe so. We'll check on it. We'll check on it. In that case, try to find the answer for 11th. Okay, 10th question. What part of ditch 48 meter long, 16.5 meter broad, 4 meter deep can be filled by earth got by digging the cylindrical tunnel of diameter 4 meter and length? Okay, of diameter. It should not be, okay. You will get radius, no? Cylindrical. Okay. See, question 10, they said you've got a tunnel. No, you've got a ditch, a cuboidal ditch, let's say. You need to fill it. Whereas you've got a tunnel. Tunnel will be like this, no? So you've got a tunnel somewhere else here, let's say. Cylindrical tunnel. You get a mud from this. You dig a tunnel here, you get mud from this and you fill it here. What part of ditch will be filled? So this value, let's say A will fill somewhere else here, no? Let's say until this area. So this volume, until this volume is covered. What part would be covered? They've given you in terms of ratio, right? I mean the fraction, right? We'll solve it. How do I solve? We'll solve it. I'll tell you. So question 10, what part of ditch will be filled? So ditch will be bigger one, the tunnel will be smaller one, right? So I can tell volume of the cuboid, volume of cylinder divided by volume of cuboid. I can tell volume of cylinder is pi r square h. Cuboid will be L into B into h. Let's say like this. 22 by 7 r square. They've given you the radius. No, they've given you the diameter. Diameter is 4. So 4 and 56. 4 meter diameter means you will get the radius to be 2 meter and height will be, height here it is length is 56 and length breadth height it is given that 48 is 16.54. 48 16.5 into 4, that's what they given, right? Yes. Now we can cut down. What can I cut down? 7 times of 8. Okay, this is for 6 times and this is for 2 times. No, 3 times. Further, is there anything I can cut? No, I can do one thing. So 22 is there, not a big deal. Here 4 into 16.5, 16.5 double, that will be 33, right? 33 again double, 66. I'll get 3 times of 66. Okay, so this one if I multiply I'll get 66. 3 times of 66, we'll have it as such. In terms of 22 table, no. Do I have anything pending? 22 by 7, 2 here, yeah. So I'll get 1 time here, I'll get 3 times here. 1 by 9 will be filled. 48 is 16.54. 48 16.54. 22 by 7, radius is 2, length is 56. Yeah, right. 1 minute. Pi r square. Again, why am I doing silly mistake? It will be 8 times again. So you will get 2 times of 22. Multiply by 2. So you will have it 2. I'll tell you again. I made a mistake. So I thought 2. Okay. Pi r square. 22 by 7 r square into h. Everything others. Okay. 7, 56 done. And 2 cut here. You can cut down. Solving them, you get the answer. Otherwise, I'll solve in a different way. Wait. 22 by 7 into 2 into 2 into 56. LBH 48, 16.5, 4. 4 they get cancelled. This is for 8 times. Okay. So 8, this is for 6 times. Okay. 22 divided by 6 into 16.5. 6 into 16, 96. 6 into 0.5, 3. 96 plus 3, 99. Okay, you'll get in terms of 11 table, cut it in terms of 11 table, 2 by 9. Yes. Why are we dividing the cylinder with cuboid? Good question. We need to find the ratio. What part of the cylinder is being filled with cuboid? Correct? What part? Out of the whole. Here the cuboid is bigger. By looking at the question itself, we can tell that cuboid is bigger. What part of cuboid is being filled? So bigger value is cuboid. In the cuboid, what is a part of cylinder? Correct? So let's say cuboid is 10 parts. Out of 10 parts, what part of cylinder is there? I need to find the fraction, right? Out of 10 parts, let's say 3 parts are cylinder. 3 by 10, can I tell? That's how I get it. So volume of cylinder by volume of cuboid. I'm just finding the ratio between them, because in the option also they've given you in terms of fraction. Okay, and from this I can also tell, from the question I can also tell that cylinder is smaller part, a smaller value, and cuboid will have larger value. Correct? Because they asked you in the question what part of cuboid is being filled. So cuboid is bigger. Part of cuboid will be filled by cylinder. So part is filled. So cylinder is smaller. You understand? Super. 11th question. Anybody? That's amazing, Anju. You've got the right answer. Okay, 11th question is the silliest question, but still, if you read the question, it will be confusing. Look at the question. Two walls of and a ceiling of a room meet at right angles at a point P. A fly is in the air 1 meter from the wall, 8 meter from other wall, and 9 meter from the point P. How many meters is the fly from the ceiling? They asked you to find one value. So in this question, 11th question, we have the ceiling. This is my ceiling. Okay, one wall, other wall here. Okay, we have got the walls, right? So this is the wall. So from one wall, so let's say this is the point P. From one side of the wall, this wall, from one side of the wall, let's say the point from this wall, so let's write this part. Okay, from this wall it is like how many meters away? 1 meter from one wall. So from this point 1 meter away, and from this wall it is 8 meter away, correct? From one side it is 1 meter, from other side it is 8 meter. Yeah, from one side of the wall it is 1 meter away. So let's say from this point it is 1 meter away, somewhere else here. From this wall it is 8 meter away. So this distance is, okay, this distance 1 meter. Let me draw it in a different color. Okay, from this wall 1 meter away here, 1 meter. From this wall it is 8 meter away, 8 meter. From the point P it is 9 meter away. From the point P it is 9 meter away. Okay, what is the question? What is the distance from the ceiling to this insect? We need to find this area. Okay, so if I consider this in a simple diagram, I'll get it like this. Okay, so here it is 8, here it is 1. We need to find this, whereas this value is given, this value is 9. What is this? In a cuboidal space, we have got a longest diagonal, longest length. What is the formula? Longest length is equal, diagonal value is equal to root of a square plus length square plus breadth square plus height square. I need to find this height. Could you imagine this? That's what I'm going to find. So how do I get it? Here, question number 11. 11, diagonal is equal to root of a square plus b square, length square plus breadth square plus height square for now. Okay, diagonal it is given that 9. 9 is equal to root of 8 square, 1 square, 8 square, let's say height square. That's what I want to find. I want to find h, right? 9, let me bring the square root there. It becomes, no, squaring on both sides, I can tell. Squaring on both sides, I can tell it is 81 equals to 1 square is 1, 8 square is 64 plus h square. So this is 65. If it goes there, 81 minus 65 equals to h square. So h square is equal to 16. Hence, I can tell h is equal to 4 meter. That's how I get it. So you have to understand the diagram properly. From the wall, from one side of the wall, it is 1 meter away. From other side of the wall, it is 8 meter away. So I've drawn like this. And from the ceiling, how many meters away? I just retrace it like this. So from one side of the wall 1 meter, other side of the wall 8 meter. From the top it is how many meters? I want to find that. Whereas from the point P, this is the point P. From the point P, the distance is 9 meter. In that case, what is the answer? Okay. Question number 11. The answer is 4 meter. What is that? My 8164. Aishwarya B. What is that? 81-64. No, it is 81 minus 65. This is 1, no. 1 plus 64 is 65. Bring it there. 81 minus 65. Okay. Now 12th question. A village having population of 4,000 requires 150 liters water per head per day. It has tank measuring 20, 15, 6 meters. The water of the tank will last for. Good question. We have the tank, and the tank has a capacity, and that capacity of water will be required for how many people are there? 4,000 people. Whereas each person will require 150 liters per day. How many days will it last for? That's the question. No, I'll tell you. I hope you're done with this 11th one. Shall we go to the 12th one? Okay, 12th one, it is like this. Volume of tank equals to number of days into volume of water, or volume of number of days will it will last into water water consumed by total population of that village. Okay, for n number of days, okay, each person will consume 150 liters of water. How many people are there? 4,000 people are there, correct? 4,000 persons are there for the village. Each person will consume 150 liters of water in one day. For 4,000 people, 4,000 into 150, so we'll have it as such. But what is the volume here? 20 into 15 into 6, so 20 into 15 into 6, we will get meter square value, correct? So 20 meter, 15 meter, 6 meter, ultimately after solving that you will get meter square. For 1 meter square, how many liters are there? I would have told you the value will be 1000 liters. Can I tell? Because for every 1 meter square, 1 meter cube, 1 meter cube equals to 1000 liters. If you multiply all the values here, you will get some value in meter cube. 1 meter cube is equal to 1000 liters. This is in liters, this is also in liters, right? If I don't write this 1000, this the value left hand side will be in meter cube, this value will be in liters. Meter cube and liters will not be comparable, will not be compared, cannot be compared. In that case, I want to convert that in terms of liters. How do I convert? For every meter cube you will get 1000 liters. Then solve it further. 0 0 0 0 0 0. Okay, and what else? 15 150 10 times, then 2 times. Okay, so n is equal to 6 by 2, 3 days. The water will last only for 3 days after solving them. Okay, 12th over. 13th, yeah, right answer is that. Similar process. 13th is similar way. We shall finish it within 15 minutes maximum. 1 liter of water weighs 1 kilogram. How many cubic millimeters? Millimeters of water will weigh 0.1 gram. So millimeter we need to find, right? Okay. Let's go to next question. 13th one. 1 liter, 1 kilogram. That's the clue given. We'll have it. We'll use it later. Okay. 1 liter is nothing but 1 meter cube. Can I tell? 1 meter cube is equal to 1 liter. What is 1 meter cube? 1 meter into 1 meter into 1 meter. Okay. Can I write it? 1 meter into 1 meter into 1 meter. That is nothing but 100 centimeter into 100 centimeter into 100 centimeter equals to 1 kilogram. Instead of 1 liter, I am writing 1 kilogram. Instead of 1 meter cube, I am writing 100 centimeter into 100 centimeter into 100 centimeter. Why? Because this is nothing but 1 meter into 1. I can write it like this: 1 meter into 1 meter into 1 meter equals to 1 liter. So instead of 1 meter, I am using 100 centimeter, 100 centimeter, 100 centimeter equal to 1 kilogram. I want to write it as grams, right? So let me convert it as. I'll do one thing. Instead of 1 liter, I am writing 1 kilogram. Instead of 1 kilogram, I am writing 1000 grams. Okay. From this, I can tell. Let's do it like this. They said millimeters, right? For every 1 meter, we'll get for every 1 centimeter, we'll get 10 millimeters. Correct? I'm even reducing it further. That is 1000 millimeter into 1000 millimeter into 1000 millimeter equals to 1000 grams. Can I tell? So 3 zeros will get cancelled. Okay. And then what is the question? How many cubic millimeters of water? 1 meter cube is equal to 1000 liters. So this is 1000 liters, 1000 kg. It is 1000 liters, no? 1000 kg. You will get 1000 kg in 1000 into 1000 grams. You will eventually get 1000 into 1000 grams. Again 1000 into 1000 grams. Right? I wrote in a different way. I thought centimeter cube. 1 meter cube is equal to 1000 liter. So 1000 kg. 1 liter is equal to 1 kg. No, 1000 liter equal to 1000 kg. So for every kg, you get 1000 grams. 1000 into 1000 grams. I just convert in terms of meter cube. Sorry, millimeter. 1000, 1000, one more 1000, one more 1000. Eventually you will get 1000 millimeter cube, because it is 1 no, 1000 millimeter cube is equal to 1 gram. I want 0.1 gram, correct? Let me bring 10 here. I'll get 100 millimeter cube equal to 1 by 10 gram, which is nothing but 0.1 gram. My answer will be 100 millimeter cube. Get it? See here, 1 meter cube is equal to 1000 liter. So 1 meter, 1 meter, 1 meter, that is 1 meter cube. 1000 kilograms. Instead of 1000 kilogram, I'm solving in terms of grams. For every 1 kilogram, you get 1000 grams. 1000 to 1000. There, I'm converting that in terms of centimeter and then millimeter, because 1 centimeter is equal to 10 millimeters. That's how we get it. So for every 100 centimeter, we'll get 1000 millimeter. Okay, into 10, no? 1000, 1000, 1000. Here 2000, 1000, thousands are there. Cancel them out, you get 1000 millimeter cube. Millimeter, millimeter, millimeter. So millimeter cube equals to, nothing is here, 1 kilo, 1 grams. Okay, so I don't want this 1 gram, I want 0.1 gram. Again, I'll divide by 10, or even I'll bring the 0 here, 1 by 10 grams, which is 100 millimeter cube. Okay. All right. Next question. A cylindrical over a tank of radius 2 meter, height centimeter, 7 meter, to be filled from the underground tank. Okay, this is similar to the question 10. Similar to the question 10. Try to solve and tell me the answer. 14th is similar to 10. Tell me the answer. Oh, yes, Anju, right answer. Cylindrical overhead tank of radius 2, height 7 is to be filled from the underground tank of the size 5.546. Okay. In the 10th question, from the cylinder you are filling cuboid. Here you are filling cylinder with from the cuboid. Okay. You're filling cylinder with from the cuboid. Okay, reverse process. How much portion of the underground tank is still filled? No, the same process only. So you're filling cuboid from the cylinder only. Same process only. I read reverse. Okay. How much portion of the underground is still filled with the water after filling the over a tank completely? Okay, fine. Volume of cylinder divided by volume of cuboid. Simple. 27. Question 14. Volume of cylinder divided by volume of cuboid. Pi r square is equal to by LBH. Okay, pi r square h, pi 22 by 7, r square 2 into 2, h 7 divided by, what is the value, other value? 5.5466. 5.546. 5.5 into 4 is 22. I can cut them. So this one, cut them. You can easily cut out. You get 4 by 6. This is for 3 times. You get 2 by 3. That is, out of 3 parts from the cuboid, you can fill 2 parts from the cuboid on the cylinder. Okay, let's say 3 kilograms of mud is there. You can fill only 2 kilograms of mud in the cylinder. So remaining 1 kilogram would be there, no? So portion remaining would be very simple. Out of 3 parts, 2 parts filled. Remaining will be only one part, no? One part will be still filled. You understand? It's a usual process. From the cuboid mud, you are filling cylindrical tank. Okay. So out of 3 parts, 2 parts will be filled with cylinder. So remaining some parts will be there. No, out of 3 parts, 2 parts filled, remaining will be 1 part. So 1/3 of the cuboid will still be filled. So we have some other mud or some other portion of the sand still be filled, which is there in the cuboid itself. Remaining part is 1/3. You understand? Any confusion in this? 15th one is a bit tricky. We'll solve it out either. Last question for the day. What is the difference between mass and volume? Mass and volume. Volume means the space it can occupy in the empty space. So my volume is whatever the amount of space I can occupy in the room. Okay, my mass is what is inside me, tissues, everything. No, that is a mass. What is inside me? So let's say a spherical ball. Okay, a ball is there, spherical ball is there. You would have find, let's imagine like this. You have two balls. Okay, one is plastic ball, other one is a stitched ball, cricket ball. Both of them, let's imagine both of them are same in size. Will they be same in weight? No, right? Plastic ball will be different in weight, will be lesser. Why? The mass inside the plastic ball will be lesser. Mass of the plastic will be lesser than the mass of the stitched ball. That's how it is. So mass will play a vital role in weight. Okay, your weight is not your volume. Your weight is mass with respect to volume. You got it, ma? Anju? Super. So x and y be the volumes for the next question. Question 15. X and y be the volumes, m and n be the masses of the two metallic cubes, p and q respectively. Okay, question 15. We have got two cubes, p. Let's take square itself. So cube p and cube q. Let's imagine like that for now. Okay, just two-dimensional figure. Now what is happening? X and y be the volumes. Okay, m and n be the mass of the two metallic cube, p and q respectively. Each side of q is 2 times of the. So here q is equal to 2p. Let's say the side of the cube is p. Side of the cube is side of the cube p is p. Side of the cube q is q. Whereas here it is given that q is equal to 2 times of the side of the p. Right? 2p. Let's imagine like that. What is the volume then? Volume is x, no? Volume x is equal to p cube. Here y is equal to q cube, which is nothing but 2p whole cube. Can I tell? I can write y is equal to 8p cube. We'll have these two for now. And then mass is and mass of q is 2 times that of p. So here mass, what is mass of this one? N. What of mass of this one? M. Okay, they've given you the clue also. What is that? Also n is equal to 2m. So these two are important. They've given you this also. You need to find these three are important. Now they've given you another equation, right? Let u equals to m by x, v is equal to n by y. U is equal to m by x, v is equal to n by y. Now find the equation, right? So what is n? 2m, y 8p cube, right? Let me use it. V is equal to 2m divided by 8p cube, right? I can write, instead of p cube I can write x, correct? I'm going to write x here. V equals to 2 by 8. Instead of 2 by 8 I can write 1 by 4. 1 by 4 m by x. Can I write m by x? Okay, instead of m by x I can write this one, 1 by 4 u. Instead of m by x I'm using the value u. Bring this 4 there. 4v equals to u. That's why u is equal to 4v. Option A. That's your answer. I'll tell you again. They've given you the two cubes, p and q. Let's imagine the side of p is p, side of q is q. Okay, they've given you that double of the p will be side of the q. Double 2 times of the side of p. 2 times of side of p is 2p. Now from this I know what is the volume. Volume is equal to x. They've given you in the question x for p, y for q. Volume. X is equal to p cube. Y is equal to q cube. What is q? 2p whole cube. So solving them you get y equal to 8p cube. Also they've given that mass of this n is double the mass of m. So also n is equal to 2m. Using these three into the given equation. What is the given equation? U equal to m by x, b is equal to n by y. That's what given in the question. Okay, so I'm using this, I'm replacing this values. What is n? I know it is 2m. What is y? 8p cube. Okay, instead of p cube, can I write x? I'm writing here. So 2 by 8, 1 by m by p cube, m by x. What is m by x? U. Okay, bring this 4 there. 4v is equal to u. Option A. So you have just reframed the equation, and don't worry, you will not get this kind of question. This is very tough. This is for, let's say, gate and all. We don't want to deal with this kind of question. But still, look at the UPSC questions. All those UPSC questions, you're dealing with the application. How well you're comparing. See, it's all about in the volume section, in the volume part, volume surface area part, you will have to deal with the comparison contents. So let's see this one. You're comparing things. Look at this. You compare. Still you compare. Look at this also. You're comparing. All the UPSC questions, you're comparing. Other practice questions, yeah, fine. You explore the contents. But in the case of UPSC question, maximum, I believe, in area and volume combined, together, you will get 2 questions. Okay, whereas among the 2 questions, one will be very easy, one will be moderate like this. If you think, you will easily find the answer, but moderate means you have to think little more to find the answer. Okay, any doubts you can ask, otherwise you're free to leave. How to find the square and cube roots? Any shortcuts? Yeah, Sharmista. See, I will tell you the shortcuts. Okay. See, thing is, you must know the the values of squares, until at least 9. Values of the square until 9. Values of cube until 9. So first we'll deal with square roots. Okay. 1 square. 1 square is 1. 2 square is 4. 3 square is 9. 4 square is 16. 5 square 25. 6 square 36. 7 square 49. 8 square 64. 9 square 81, and 10 square 100. So leave this 10 square. Anyway, if it ends with 0, some number will end with 0. Obviously, square root of that number will end with 0. Simple, right? So we'll find the values. Okay, let's take the number. Let's take a random number like 1024. What is the square root of 1024? Okay, I want to find the square root of 1024. See, this method, this shortcut method will be helpful if you want to find the square root of perfect square. What is perfect square? These are all the perfect square. 81, 64. Okay, if you find the square root, the value will be a whole number, a real number. Okay, sorry, not real number, the integer value, natural number, let's say. Okay, so the result of this will be natural number. How do I get it? I'll tell you. Whenever you get 4-digit number or 5-digit number, whatever it is, take the last 2-digit number away. Last 2 digit. In the last 2 digit, check with the last digit. 4. Okay. When squaring a number, you get 4. What are the possibilities? You may get this one, or you may get this one. Correct? You may get either 2 or 8. Okay. So whenever you square root a double-digit number, or sorry, 4-digit number or more, maximum 4-digit number to 6-digit number or 5-digit number, you will get, whenever you square it off, you will get 2-digit number. Correct? So it can be either 2 or it can be either 8. Okay, just think of it, either 2 or 8, because whenever I square I get a 4, no, so it can be 2 or 8. That's what we have right now. Now this 10, no, this number 10, the number 10 is between 2 squares. 2 squares means like 3 square and 4 square. The 10 is between 9 and 16, correct? So the 10 is between 9 and 16, 3 square and 4 square. Now multiply 3 and 4. What is 3 and 4? 12. For now, let's imagine. So 10 is between 3 square and 4 square. So let me write 3 here, 3 here. Simple. Okay, let me write 3 here, 3 here. Now multiply 3 and 4. What is that? 12. 12 is there. 10 is there, no? If 10 is lesser than 12, smaller number. If the result is more than 12, bigger number. Now the answer is 32. Okay, it will be a little tricky. I'll tell you again. It's actually silly. Okay, 1020. What did I do? I split the last two number, took it out. Last two number, take the last digit. It is 4. So whenever I square a number, I'm getting 4. That means I've got two possibilities. One is 2. Sorry, one is 2. Other one is 8. So double digit number will be there. 2 here and then 8 here. It can be any number. And now 10. Now check with the remaining part inside the part. Okay, so first two digits, it is 10. The 10, the value is between 3 square and 4 square. Correct? You must remember these values. The value is between 3 square and 4 square. What is 3 square? 9. What is 4 square? 16. It is between, right? Okay. Now I have to check with the least number. 3 and 4, least number is 3. 3 here, 3 here. Write it down. Okay. And now I want 3 here. No. What is the next number of 3? It is 4. 3 4s are 12. Right? 12. I've written here. If this number is lesser than 12, smaller number. If this number is more than 12, bigger number. Okay, I'll tell you one other number. So let's take some other number. 1296. Yeah, 1296 is possible. Okay, lesser than the number, it is 10. No, a smaller number. More than or equal to the bigger number. I'll tell you. 1296. Fine. Yeah, we'll take 1296 itself. Root of 1296. Let me take the last two digits. 96. No, I get either 6. Anything else? 6, 4. Okay, I may get either 4 or 6. Correct? 12. It is between 3 square and 4 square. So let me bring the last 3 digit. Sorry, least digit 3 3. Okay, let me write the least digit 3 3. What is the next number of 3? It is 4. 3 4s are 12. If 12 is, if the result is lesser than 12, least kuti number among them. Sorry, small number among them. If the result is more than or equal to this value, bigger number. 36 square is 1296. You understand? That's how we get it. This is what square root. Okay, so let's take another value. Let me give you some other value. Try to find the answer. Let's take 9801. 9801. Find the square root of 9801. Simple question. Charmista, can you find the answer? Try to find the answer, ma. What is the square root of 9801? Let me solve it here. Square root of 9801. So last two digits. So either I'll get 1 9. So 1 square is 1, 9 square is 81. So I've got two different varieties. 98 is there, no? 98 is between two number squares, 8 square and 9 square. No, 9 square, 10 square. 9 square and 10 square, right? So I can use the least number, 9 here, 9 here. And then, very good, 98 is the right answer. And then what will happen? 9, next number is 10. 9 tens are 90. If this number is lesser than 90, smaller number. This number is more than or equal to 90. Here it is more than. So I'll go with the bigger number, 99. That's how I get the answer. Sharmista, you understand, ma? Super. Similarly for cube. Cube is similar process. Same, 1 cube, 2 cube, 3 cube, but here a little trick. You can easily find the answer. 1 cube is equal to 1. 2 cube is equal to 8. 3 cube is equal to 27. 4 cube is equal to 64. 5 cube is equal to 125. 6 cube is equal to 216. 7 cube is equal to 343. 8 cube is equal to 512 and 9 cube is equal to 729, right? Now look at it in the previous case. For the squares, you've got two different varieties for a, whenever you get double digit here, no digits here, whenever you square, you get 1. So you've got two possibilities, 1 here, 8, 1, 9 here. But here, whenever you cube a particular number, you get some number that last digit, no unit digit, they are not repeated. You don't have any other possibilities. Okay, let's take silly number 1728. Okay, root of 1728. Okay, okay, so very simple. Last three numbers, take the last three numbers. There cube last two digits, here last three digits. Okay, so this is ending with 8. So last number should be, so 2 digit will be there, 2 will be there, 1. Whose cube is 1? 1. 12 cube is 1728. Okay, so let me give you some other number like 17 576. Okay, try to find the answer. Let me tell you how to find the answer. It is ending with 6. No, only one possibility is there, 6. So whenever I double two digit number, I triple, I find the cube of double digit number, it will be either 5 digit number or 6 digit number. So obviously it will be a double digit number, no other go. It is ending with 6, no, it has to be 6, no other go. Last three digit numbers. 17. Okay, 17 is a number. Okay, it is between 2 cube and 3 cube. 2 cube and 3 cube. Who is a smaller value? 2. 26. That's how we get it. You understand? 26 into 26 into 26, 1756. You understand? Okay, last question. You try to find it and we shall leave. Find the cube root of 571 787. 571 787. 571 787. Superb, superb. Siddharth, yes, right answer. Rupasri, right answer. Sharmista, Anju, right answer. Yes, ma, right answer. 83, right answer. So it is ending with 3, not a big deal. 7, no. 3 cube 27, 7, so 3. 571. So it is between 8 cube and 9 cube. Smallest number is 8, 8 cube. That's it. Simple. Okay. So hope you understood. If you have any other doubts, you can ask me. Otherwise, you're free to leave. Cube, square root. Cube root, square root. You found out. Yes, ma. Okay, okay. For square root, you must remember 2 possibilities will come. For cube root, only 1 possibility will come. Easy. You can easily find out. All right, guys. Any other doubts? Okay. Yeah, thank you, Anju. I'll wait for 1 minute. If you have doubt, you can ask me. Otherwise, we shall leave. I'll leave. Okay. Thank you, Veerasamy. Thank you, Rupa. Yeah, thank you, Shiva.
Recording stopped.
All right, guys. See you. Thank you.